Okay, it is recording now. Let's do this. We finished EFA this morning. Next is CFA. Excuse me. Just going to open up the slides real quick. Excuse me. We've talked about CFA a little bit already. We're going to do the same as we did with EFA. I'll show you a few slides, but then really we're going to go through it and do it. There is so much to do with CFA, like a lot. So hopefully we'll get through all of it. Here's all the stuff you do with CFA and more. We're going to work through most of it, hopefully all of it. But essentially the way to get from EFA to CFA is you take your pattern matrix and you create a CFA model out of it in Amos. If you're using PLS, you can do the same in PLS. I have a plugin that'll do it for you in Amos. Sometimes it works. Sometimes it doesn't work. So we'll see. Hopefully it'll work this time. If it doesn't work for you, maybe you can catch me during a break and I can help you get it to work. I think that is all I want to show you right off the bat. And then we'll go through the slides after. So here's what we need to do. This is going to be kind of clunky for a sec. Who's going to be following along with the data doing a CFA, like following along one-on-one? Yeah, a few of you? Okay, so, yeah. Is that possible if you share the Oh, yeah. Yeah. I'll share the CFA results. EFA results. Oh, no, did I close it? I closed it. It didn't save. It'll be easy to recreate. Whoops. Yeah, did anyone save it? I got it. I'll recreate it real quick-ish. Take me a couple minutes. Sorry about that. When in doubt, save. Says the man who didn't. Here we go. Now it's opening. While I'm doing this, here's what I need you to do if you're following along. I need you to go to get the plugins, StatWiki. There is, actually they're in our shared folder, I think. Here, in our shared Google Drive folder, if you look at estimands and plugins, there is a plugin we're going to use. If you have Amos version 24 or 25, you'll use the ones in this folder called 24 or 25, or 24 or higher. If you have Amos 23 or lower, use the ones in 23 or lower. You should all probably have 25, yeah? 24? Okay, so use version 24 or higher. And the plugin you need is called Pattern Matrix Builder. Actually, I'm just going to have to show you how to get that all in. So we'll be right back. Here we go. I'm going to recreate this real quick. Or if you want, you can watch silently the video on YouTube on how to do it. Look up Amos plugins version 24. In the meantime, I'm going to recreate this CFA real quick, or EFA, excuse me. Recent. Yes. Yeah. Okay, I think that was it. Yep, that looks fabulous. Great, that was it. So I will save this output as EFA RMIT MC final. And oh boy, it has hidden. Oh boy. Google Drive, there we go. Okay, SEM Bootcamp and data. Okay, I'm saving it right here in the data folder. If you were to go to, in our shared drive, if you go to the data folder, it is right here. So Google Drive, SEM Bootcamp, data, in the data folder, it's this top one, EFA RMIT MC final. Just edited. It says 8:18 p.m. That's what time it is for me right now. But that's the final. If you were to double click that, that would open it up in SPSS as the final pattern matrix. Okay. Okay, so what we're going to do, I'm going to show you real quick, not real quick, I'm going to show you how to build a CFA in Amos and how painful that is, and then I'll let you use the plugin to do it automatically, which is way less painful if it works. Hopefully it works. So, over in Amos, if you don't know where Amos is on your computer, go to the Start menu and type Amos. And you're looking for Amos Graphics. Yep, Amos Graphics. I'm using version 25. If you're on 24, it doesn't make much of a difference. Don't worry too much about it. Yours should open up and look like this, just a blank canvas. Amos was made back in the 1980s or early 90s when graphical user interfaces were awful, and they decided not to update it since. So we're going to be using an amazingly awful graphical user interface. It's going to be great. Also not intuitive. So to create your factor analysis in Amos, what you have to do is, zoom in here. First, connect your data. To connect your data, you can either go to File, Data Files, not Open. If you click Open, it won't let you open data. You can go to File, Data Files, or you can use this button down here. It looks like a spreadsheet. I use the button there. If you click on that, it'll open this little dialog. And if you double click the group number 1, it'll let you go find the data. For us, that data is in the Google Drive. SEM Bootcamp data. I'm going to use the Bootcamp trimmed, or no, MC trimmed, sorry, MC trimmed. And then hit open, and then it should show up here. If you opened it correctly, you should have an N, a sample size, 378. I'll do this all over again, don't worry. Hit OK, and nothing happens, which means you're good. Again, for those who are just picking this up, after you open Amos, click on this button down here. This one that says select data files to go get your data. And then double click group number 1 to go find your data and hit open. When you're done, hit OK. Okay, and again, nothing happens. But if we were to click on this white stacky thing, I'm not sure what it's supposed to represent, but it's a white stacky thing. It would show you all the variables in our model. Those are all the variables. Yours might not look identical to this, but it look pretty similar. And what we have to do to create a factor analysis is click on this candelabra thing. I'm really not sure. But you click on the candelabra. Don't click and drag. Just click it. And then over in your canvas, you're going to click and drag to make a specific size. Just make it any sort of oval size. For me, that was too big. I'm going to make it a little smaller. So, something like that. And then if you click on it again, it adds an item. and not super intuitive, but now you know how to do it. What we would have to do is look at that pattern matrix over here and say, well, for factor 1, or let's just from top to bottom, for anxiety, we have 7 items. So we have to click on it 7 times. Well, that was 8, whoops, 7. And then we'd have to create another one. Click. You don't have to click and drag the second time. You've already established the defaults for the size. The second one would be 4 items. That's comp use. 1, 2, 3, 4. And another one has 7. You get the idea, right? Really painful. And this is the easy part. What you'd have to do after this is click on the white stacky thing and then drag anxiety. Ooh, and now you can't even see it. I'll have to fix that too. Drag items into the boxes. Very not intuitive. So we made a plugin for it. First things first though, go to edit, and then ignore everything in edit and go over to view. There we go, view, and interface properties. I'll show you again in a sec. Go to view, interface properties. We have to set a preference real quick. In the miscellaneous tab, uncheck display variable labels, because that's going to display the entire wording of the survey question. So that's in interface properties from the view interface properties option, miscellaneous tab, display, uncheck display variables. And then just close that. Okay, back to where we were. So the way you would drag an item in is you click on this white stacky thing right here next to the blue stacky thing, and it opens up your data set if you've already loaded your data. And then you can click and drag items into boxes, which is painful if you have 100 items. We have 47, I believe. So this would take a while. You can also just double click on a box and name it anxiety _2 or something like that. As long as it's the same name as your variable, it recognizes it. So let me show you an easier way. Now that I've showed you the hard way. I showed you the hard way because for some of you it won't work, the plugin. So, well, that didn't work either. Something like that. File new. Okay, I'm so glad this happened. This incredibly intuitive error happens now and then. It means close and reopen. It has an internal error. Amos is not a well-supported software application by IBM. They acquired it a while ago and just haven't maintained it. But it's still, believe it or not, the best covariance-based SEM software out there. I'm thinking of remaking one and calling it JAMUS. We'll see. Okay, so I'm gonna have to close Amos. More errors, hit OK, it closed. If you didn't get that error, good. Open up Amos again. Connect your data. File, data files. Find your data just like before. Okay, blank canvas. There's a plugin that'll build your CFA for you. To use it, what you got to do, go over to this data folder. Sorry, to the SEM Bootcamp folder. Go to Estimands and Plugins. Go to version 24 or higher. And this is the one we want, this pattern matrix builder, Amos version 24. The first thing you have to do, drag that onto your desktop or something, or make a copy of it. I'm going to make a copy of it. Copy. And just paste it onto your desktop for now. We're going to move it, but paste it here for now. It should show up right here. Once you've done that, right-click it, go to its properties. This is critical. If you don't do this, it won't work. Go to his properties. Make sure there's no button down here that says block. If it says block, unblock it. Or if it says unblock, check that box. Otherwise, it'll be blocked and it won't work. Mine doesn't have it. Some of yours might have it. I haven't figured out if it has to do with your preferences or your security options or what. Now, open up a file explorer. Just a Windows Explorer here. And on the left, go find your computer, this PC. Click on that. Click on the C drive, or double click it, I guess. Double click on Program Files x86. If you don't have that, then talk to me later. Go find IBM. Actually, I'm putting it in the wrong place. They changed it. Sorry, let's back up. This is for version 23 or earlier. My bad. Okay, go back to the C drive. Go to the users folder. Click on your username, whatever it is. Mine is Jay Gaskin. Yours might be whatever you are. And now here's the trick. There's a folder called app data that is hidden from regular users. In order to see that folder, you have to click up here on the View tab. Click up here on View. And on the right, check the box for hidden items. While you're at it, check file name extensions. It's useful, but not pertinent to what we're doing. But check this hidden items. Once you do that, app data will show up. It's a hidden folder. Open up app data. Go to local. Go to probably IBM. IBM. Go to SPSS. Statistics. Version, whichever yours is. Mine's 25. Yours will probably be 24. I'm going to go to 25 for me. Is yours different? They've changed it. Ah! Where did they put it? Well, poop. Oh, nope, I remember. Forgive my language. Okay, my bad. All right. I'm so sorry. Here it is. Go all the way back to app data local. Sorry, wild goose chase. I'm just trying to teach you about your directory structure. Now you've learned more. Sorry about that. Go back to the local folder. They created a new one. It's called Amos Development. That's where you need to put it. Open up Amos Development. Again, that's in the app data local folder. Open up Amos Development. Open up Amos. Open up whatever version you are. And then there's a plugins folder. It is so hidden. Plugins. We are so deep down the rabbit hole right now. And now you'll see some, you won't see all these. I have a bunch of extras because I do this stuff. But you'll see some plugins. You now need to go back to your, wherever you saved that copy of the plugin, the Pattern Matrix Builder plugin, and drag it in or cut and paste it in to this folder. If your computer says you may not do that, does anyone say that?
Security.
Yeah, is there a security warning?
Yeah.
Go ahead and click through it. Say yes. Yes, I do want to do this. Okay, next step. You'll never have to do that again unless you want another plugin. Then it's recorded. There's also a shorter video where I actually do it correctly the first time. So the next thing you need to do, close Amos. It'll ask you to save. Go ahead and save. Yeah, I want to save my changes. This is going to be CFA. I'll change it. I'll save it in our folder. You save it not in this folder. You save it on your own computer somewhere. Amos. I'm going to call this RMIT CFA. Okay, so close Amos. Now, very importantly, last step. And again, you'll never have to do any of that again. Open Amos as administrator. So the way you do that is you go find your Amos icon and right click it and run as administrator. Run as administrator. Every time you want to use one of these plugins, you'll probably have to run as administrator. Did it open? Oh, no license. What? Sometimes Amos will do that to you too. I have a license, I swear. Wow. Is it Amos? What version was it trying to give me? This one. I might have opened version 24. This is 24 it's trying to open. That's my problem. It's going to say no license. Yes, thank you. Here's version 25. There we go. Okay. So hopefully your Amos opened. Okay, now when you click on plugins, you should see something called, you should see a pattern matrix builder. Why don't I see that? Oh, I feel like a failure. All right, I'm going to go get it. Yeah, pattern matrix model builder. I'm going to go put it in my folder. See, now here's the thing. I fail in front of you for a very important reason. So that you know that failure can happen even to the supposed experts. So that when you fail, you'll be like, you know what? James failed too. I don't feel so bad. And he failed in front of everybody and while being recorded. I'm failing in my room. Okay. There we go. Let me put it in here. There it is. Okay. Now I've got to restart Amos. Please work. Hey, there it is. All right. You should have a pattern matrix model builder. Hopefully. And all this effort will have been worth it, I promise. If you've loaded your data file, like we did before, now if you go copy that pattern matrix from the EFA output, just right click, copy, and go over to Amos, go to plugins, click on pattern matrix model builder. It'll pop this thing up. If you just paste that pattern matrix in there and hit create diagram, it will think and create it for you. Yeah. Ooh. But now you can do that as many times as you want. You don't have to go through all those steps again. All you do is click on plugins, pattern matrix model builder. Yes. And if it's not already built, it'll actually build something. Again, you just have to copy over that pattern matrix. Do I need to do that last set of steps again, or are we good? Oh, yeah, okay. Okay, I figured. Okay. Close. No, don't save. Open. Do you have your data loaded? Okay, let's load our data. Okay. So, to load your data, click on File, Data Files. Once you've clicked on Data Files, this little dialog opens up. Double-click group number 1, or just click on File Name. Either one will do, File Name or group number 1. And go find that data. Our data is MC trimmed. And then hit Open. You'll know it loaded properly if you get an N, if you get a sample size number. After that, hit OK. And then it's set. You have your data, so go to Plugins. Again, plugins, pattern matrix model builder. And then this opens up this big dialog. And inside here, you're going to paste the pattern matrix. So you're going to right click the pattern matrix, hit copy. And then you're going to paste it in that dialog area. And hit this button that says create diagram. It thinks for a while, and then it produces it all magically. And everything's in there. Everything's constrained properly. The only thing you need to do at this point is change the names of the factors. Okay, did it work for you? For some of you? It worked? Yeah, yes. Okay, if it doesn't work for you, it might be because of the decimal notation. In Australia, do you guys use point or comma notation?
Point.
Point, excellent. Okay. So, but if you have an alternative language on your operating system that uses comma notation, then you might need to change it to decimal notation. Yes? Oh yeah, so after plugins, click on Pattern Matrix Model Builder. This one. And then you'll paste the pattern matrix into the open window. Okay. Okay. So there you have it. That should work with your models too, not just this one. It should work with any model you've done an EFA for. And if it doesn't, I apologize. I've made it as robust as possible, but you can't foresee every error. And you can create it manually. If you don't remember how to create it manually, there's a video we just created, or you can Google. There's a video that does this for you. Let me show you real quick, just so you have reference for it. You could go to YouTube and search for CFA model fit. And in this video, CFA model fit, this shows you step-by-step how to go from a pattern matrix to a model CFA. Yeah. By the way, never search for model fit on YouTube in front of an audience. Bad idea. Yeah. I did that without putting CFA first. Bad idea. Okay. Here we go. So there we have it. This is the model we're going to work with. Let's go ahead and figure out what these are or should really be named. We have to rename these. So to rename them, you just double click them. Here we go. And double click this and call this one useful. Useful. You know, we have some factor scores, and I think one of them is called useful. So we can't have this called useful. It's got to be like useful F, Z. I like Z, usefuls. There we go. It just can't be named the same thing as a variable we already have in our data set. So usefuls. We can now click on this one over here. This is anxiety. With a Z at the end, because I think there's one in our data set called anxiety. This one's playful. Playfuls. This one is decision quality. Information acquisition. So building a CFA of this size can take you an hour without the plugin. And then when you finish, you realize you messed up somewhere. You have to start over again. So hopefully the plugin works for you. Soch des one. Let's call it A. Soch des or positive. Pause. And this was Soch des negative. If you don't call them the exact same things as me, you're fine. In fact, I'm going to call this one Bob. You can call this one Bob, and it would still work. So just name whatever you need to. negative. Okay. So you should have something that looks roughly like this at some point. Just name all those factors. I strongly encourage you not to put numbers in your factor names. Also, don't put spaces in your factor names, because some programs will break when you try to use factors with spaces in them, in their names. Also, don't put hard returns in those factor names or any mathematical symbols. Yep. Okay. That is our CFA. We can now run it. Am I going too fast? Too slow? We good? Oh, wait, okay. That gives me time to get some water. Right there. No water. Okay. Yeah. I'm spending a lot of time in the workup because until you get to the right spot, we can't move forward. Did you copy it directly from the SPS? On the data, like you. I'll say, for those who are following along but weren't able to follow along, I will save this file in our Amos folder so you can use it. So saved. So this is the RMIT CFA in the Amos folder. Oh, not this folder. Google Drive. There it is, in the Amos folder. RMIT CFA in the Amos folder, in our bootcamp folder. Okay. How many are still following along? Yeah? Okay. Okay, so I just need to know if I need to go at a certain speed. Did it work? Do you have a model functioning? Maybe? Sort of? Yeah. Okay. Did it end up working over here?
Yeah, sort of.
Okay, good. Okay, cool. All right. So now we can actually run this. There's some options we need to check first. First things first, you have to go to the colored abacus. That's what this is. It is an abacus, like a calculating machine. There's a colored one. Go to the colored one. No rhyme or reason, just it's the analysis properties. How on earth are you going to remember this? That's why I made videos, so you don't have to. To be very honest, last night I watched a video. Oh, thank you so much. I watched one of my videos so I could remember how to do something for today. Like, it's cool. That's why I made the videos. Okay. So in this analysis properties, again, that was the colored abacus over here on the left. Click on the colored abacus. It opens up analysis properties. You want to go over to the output tab, and you want to check the box for standardized estimates, because we want to get standardized estimates. Everything else, there are a lot of other things you can do here. Don't worry about them just yet. Oh, that's a new one. I've never seen that one before. D-separation. I don't even know what that is. Okay, standardized estimates. Close it. There's no like OK button or confirm. You just close it. I don't know why. And now it will calculate standardized estimates after you save it with the floppy disk. Some of you remember floppy disks. I do. I'm old. And hit calculate estimates, which is the not colored abacus. This one right here under the magic wand. Who knows what that's for? Actually, I do. We'll use it later. So you're gonna hit the color or the not colored abacus. It's gonna think for a sec and then throw you an error. What? You gotta be joking me. I have a license.
Same happened.
Yeah. You get the error too? I'm stupid Amos. All right. I'm so glad we all got that error. Save your model, close Amos, reopen it. Tell you what. All right, now, for those of us who are more than 25 years old, this will not seem weird that we have to close and reopen programs a lot. That's what we had to do, like all the time. Things didn't work. Okay, it didn't work. Close and reopen it. Reset, reset. But, you know, younger generation, everything's just supposed to work, right? Okay. Open up Amos again. Please work. Run it just for the, hey, it ran that time. What do you know? Did yours run? Whatever. Okay. I wish I could tell you there's like a rhyme or reason to it, but no. Okay. When you run it, you'll see that nothing happened, right? Yes.
Like say, the computer say that observable useful is represented by.
Oh, yeah. How many people got this error that says observed variable? What does it say again?
The observable useful is represented by the clicks in part.
Yeah, the observed variable useful or whatever variable name is represented by an ellipse. If you got that error, that means you have a variable like this one, and it's named the same thing as a variable in the data set. So that's why I named mine usefuls with a Z at the end, or a Z. Do you guys say Z here? Z or Z?
Z.
Okay. Okay.
Some people say Z also.
Okay, Z. Ah. Okay.
This has to be named different from the variable.
Yeah, it has to be named different from a variable in your data set.
Even though the variable named anxiety plus number, like anxiety.
No, so we created a factor score called useful already, and a factor score called anxiety, and one called playful. So there's a variable in our data set called useful. So we can't name a latent variable useful. That's why I call it usefuls. You guys also say H or is it H?
H.
That makes way more sense. I have a 4-year-old. She's in preschool, and she came home and said, "Daddy, I'm confused. Y starts with W, and W starts with D. H now starts with H, or H." Okay. Anyway, sorry, I diverge. So after you've run it, if it worked, nothing happens. What you have to do is you have to click on this up arrow, because that's what you have to do. It's not me. Okay. I used to answer my students' phones if they rang in class. All right, if you click on this up arrow, it shows all of the estimates. We're getting closer. But these are all the unstandardized estimates. We want to look at the standardized estimates. To see the standardized estimates, click on this button, standardized estimates, right here, next to the fax machine. Okay, standardized estimates. Once you do that, now this is what we want to see. You know how it should work? You should have to click one button and everything happens. You have to click on the same buttons every time. Okay, what we have here is the CFA, where we have loadings for each factor and their correlations. You may remember in PLS, we didn't have all these correlations. In covariance-based SEM, it assumes correlations between all exogenous variables. These are exogenous variables because nothing's predicting them. So that is an assumption of covariance-based SEM. It is not part of PLS SEM. Anyway, so we have the correlations showing. And these little things on the left, these are error. In PLS, it is implied. In covariance-based SEM, it is explicit. It's drawn. You can actually see it. It's the error. Remember those 3 wavy things? This is the error variance. This is the trait variance. The method variance we haven't captured yet, or the response variance we haven't captured yet. But anyway, so that's what these are. So let's look at them. We can sort of eyeball it and see if it's any good. see if we have valid constructs. The whole purpose of the CFA is to validate your measurement model. So let's validate our measurement model. If we go look at usefuls, it looks pretty good. Those loadings there, all above 0.7, and they're loading, obviously the average of above 0.7, looks pretty good. We could also look at its covariances, or correlations in this case, with other factors. We want these all to be less than about 0.8, or else they're going to be too highly correlated. And you can see these are pretty good. We can go and look at the rest in a minute. Anxiety, we got a couple low ones. We saw that in the EFA as well. So it should match the EFA pretty well, though not identical. We average out clearly above 0.7, so we're pretty good. Scroll down. Okay, playful, looks pretty good. Average out above 0.7, nothing too low in there. Decision quality looks fantastic. Information acquisition looks pretty good. There's a 0.59 here, that's pretty low. That might end up being a problem in the end, we'll see. And then these last three. We have, looks great. Have some problems here, 0.51, 0.56. You remember the social desirability factors from our EFA weren't that fabulous, right? So I wouldn't be surprised. I'm not surprised here. What about this guy? That's a problem. That's called a Haywood case. It's an estimation issue. This often happens when you have only 2 indicators on a latent factor. So there's a way around that. In Amos, you can do some model tweaking that makes things work, that doesn't totally invalidate your model. We will be doing a little bit of that. So first things first, let's address this Haywood case. The way you address a Haywood case is you have to unfreeze your model by hitting the down arrow. Down arrow way up here. And it removes all those values. And then we're going to move the constraint. Oh, so many little things. Notice there's a 1 on each of these factors, on at least one indicator for each factor. That is a requirement of covariance-based SEM. You have to anchor, essentially, the variance on a latent factor. In order to do that, we can either put it on one of the indicator's regression rates or put it on the factor itself. We're going to pull it out to the factor itself for all of these real quick. Don't ask me why. The answer is 'cause. Just trust me on that one. It has something to do with the way it's all calculated. Okay, so to do that, double click that, that first 1 down there, and it should open up this little dialog box. Pull this down here. Go to the parameters tab, and where it says regression weight of 1, delete that. And instead put a 1, I'm going to click on the latent factor itself and set its variance to 1, placing the anchor on the latent factor. What this is doing is it's allowing for the latent factor to not be biased towards a certain indicator. It puts the anchor at the latent variable level so that there's no bias at the indicator level. Again, if that doesn't make sense, don't worry about it. Trust me on this one. We're going to click on this next one, delete it, add a 1 to that factor. It's just by clicking, adding a 1, deleting this 1. And you think again, why didn't they just make it so this happens automatically? Like, what a terrible design.
Can you edit from your
From the plugin?
Yeah,
I'd have to let's see, could I do it? You could, actually, yeah. Thank you. I think I'll do that. Not ready for this class, but that's a great idea. Okay, so you should have something that looks roughly like this, where all the regression weights are unconstrained and all of the variances are constrained. Will that change our output? If I run this again, are we going to see the same loadings? And the answer is, yeah, they'll probably be about the same. Probably still see that Haywood case. Use that up arrow there. You can see, yep, sure enough, nothing's really changed. What will have changed is the unconstrained regression weights, and we'll use those later, so it's nice to have them unconstrained. Okay.
Sorry, can you
Yeah.
talk again about the constraint that 2 indicator to 1?
Yeah. Oh, fixing this?
Yeah.
We haven't done that yet, so let's fix it. So the way to fix this weirdness right here, this Haywood case, is hit that down arrow so we can mess with things. Down arrow unfreezes things. Go back and you're gonna do a tweak. You're gonna double click that line, and instead of a constraint of 1, what you're gonna do, let me bring this down here. Instead of a constraint of 1, you're gonna do a constraint of A, and you're gonna give the same constraint to this other line. So both lines are gonna be constrained to A. This is just all the little loophole, all the little hoops we have to jump through to make this work. When you name 2 lines the same thing, it's the equivalent of saying force them to be equal. And what that does is it suppresses the Haywood case and inflates the suppressed regression rate. And they'll be equal at the unconstrained level, and then they'll be better at the, or at the unstandardized level, they'll be better at the standardized level. So I'm gonna just run it again, and notice if I hit the up arrow, it fixed it. There we go, 63 and 67, which is about right. Okay. Do you hate Amos yet?
Yeah, almost.
I'm not naming my son Amos.
Sorry, but when I turn from unstandardized to standardized, all the number
Oh, disappeared. So yeah, if you're not seeing anything when you click on standardized, what you need to do is click on this colored abacus and then go to the output tab and then check the box for standardized estimates. Yeah. And then just close this window and run again. Yeah. Okay.
So for the factor which has 2 unique factor, we can constrain them to 1 or to A, the same.
Yeah, for factors that have only 2 indicators, if there's a Haywood case, meaning there's an estimation oddity going on, yeah, then you can do this thing where you constrain them both to be A. If you have another one like that, don't constrain those both to be A because that'll force them to be equal to the other ones. Constrain them to be B or C. Yeah. Yeah. Okay. Okay, so what we just did, we built a CFA, we roughly confirmed our factor structure from the EFA. We observed that we have fairly valid factors, at least convergently, except down here. These guys aren't very good. We didn't expect them to be good because they're social desirability. We looked at the correlations. They're low enough. The highest one here is 0.69, which means it's going to be less than 50% shared variance, which is good. So next, here's what we have to do. What we have to do is go to the stat wiki and figure out what we have to do. Because you will forget, I will forget the order of operations. So I wrote them down. In the stat wiki, in the guidelines page, there's for 0.6, it's the order of operations of what to do. We've already done in this MasterClass, sort of number 1. We definitely did everything from number 2. We cleaned and screened our data. Number 3, same thing. Number 4, we did all of our EFA. We're now on number 5. Number 5, obtain a roughly decent model quickly. We did that. We have roughly good model. We can look at model fit real quick to make sure it's okay. Then we have to do this very unfun thing called configurable metric invariance, which we'll do next after we look at model fit real quick. If I go too fast, if I say something that doesn't make any sense, feel free to stop me. There's a lot we're going to go through. Okay, feel free to ask questions. Don't be shy. Here we go. We've looked at the validity a little bit. Let's look at model fit real quick. To look at the model fit, there is an output menu with a bunch of results. It's next to the floppy disk. It's called the view text. Click on view text. And there are several little things we can look at. If we want to look at model fit, there's a section for model fit right here. And here we go. Let me close this a little bit. Okay, lots of measures in here. The one we want to look at is CFI. We need a CFI. At this point, we're cool with 0.9 or above. 0.95 is the ideal. You want to have up above 0.95. But for right now, we're just doing a rough model. 0.9 is great. We're looking good. We can scroll down. There's also another one down here called the RMSEA, root mean square error approximation. We want this less than, depends on what literature you read, less than 0.06, less than 0.05, less than 0.4, less than 0.08, less than 0.1. Depends on who you read. I like less than 0.06, which works. So that's good. And then you want this p close to be like the p-value for the chi-square, where it's not significant. So this is good. It means we don't have bad fit. The reverse, it's a, yeah. Bad p-value is good in this case. So we actually have a pretty decent model with no adjustments. If we want to look at the validity, we can add another plugin. Let's do that real quick. Hopefully you have that folder still open. If not, here we go. Go get that plugin from Estimands and Plugins from our shared folder. Version 24 or higher. Master validity. Oh, I have a model fit one, that's right. We just made a new plugin called Model Fit. It does model fit for you. We should try that. Let's get both of these. Oh, it's in the Google Drive SEM Bootcamp. Estimands and Plugins, version 24 or higher. Grab both of these, Master Validity and Model Fit. I totally forgot we had the Model Fit one. I'm just going to copy those, stick them to my desktop, make sure they're unblocked. Don't double click them. Make sure to right click them. Properties, make sure it's unblocked. That one's not blocked. Good. Properties, yep, not blocked for me. And then I'm going to copy them, cut them, and paste them in the correct folder, which for us was that long string, deep and buried app data, local, Amos development, Amos 25, plugins. Cool. So it's, let me zoom in. Here, if you've forgotten where it is, it's in your users. Here we go. The C drive, users, your username, app data, local Amos development. Okay, so what we've just done, put in two more plugins. See if they show up in Amos. You might have to save and reopen Amos. Yours show up. I have Model Fit and Master Validity. Do you guys have these ones showing up already?
Yeah.
Oh, we have to restart? Okay. So don't forget to save and restart. When I first took SEM, while you guys are getting that running, when I first took SEM back in 2009, I was attending a class where it was an executives class, a bunch of CEOs and CTOs and CSOs, C-suite guys. And the professor was having them do data entry and formula, like calculate formulas and do all these, like dragging in boxes and naming them and all this stuff manually. It was driving me nuts. I didn't even like doing it, and I didn't have better things to do. So we made all these plugins to automate it. Here's one of them. So if you open it back up and you go to plugins, Master Validity, Hopefully it works. And it should produce an HTML page with everything you need. Before you had to like manually calculate all this. What a pain. Yeah, like Amos doesn't even produce a correlation matrix for you. You'd have to go create that yourself. So we do it for you. Here's the correlation matrix and the composite reliability, which we talked about before. It's like the complex alpha. And the ABE, which is supposed to be greater than 0.5. Obviously, we have some problems there. That's why they're colored red. Ignore these two columns for now. Don't worry about those. But here's our correlation matrix with, on the diagonal, the square root of ABE. If any of them are problematic, it'll turn them red. Looks like we're pretty good for discriminant validity here. It did identify some concerns. Reliability for both of the social desirability scales. That's a problem. Also convergent validity for these two. So these are both a problem. What do you do at this point? If it's these factors, social desirability or another specific bias factor, I wouldn't worry about it too much because we have discriminant validity. We're good here. We have discriminant validity because the square root of ABE is greater than any of these correlations. Also, I'm not worried about it because it's close-ish. These aren't very close, but the CR is pretty close. And our EFA worked out. If it were a factor it was like key to my theory, I'd be more worried. If this was the useful factor or the decision quality factor and it was really low, I have a major problem because I can't predict something that has no reliability. It's like trying to shoot at a moving target. It's really, really hard. A lot of error involved. And what do you do at that point? Well, then you got to go back to the drawing board to figure out why that factor is not valid, which you should have already figured out in your EFA or during your data screening. So it shouldn't pose a problem at this point. And that's why we're not seeing a problem with all the others at this point, because we've already taken care of that in the data screening and EFA. Okay. Ooh, we even include, here's even a reference if you need cutoff criteria for all this stuff. Cool. So that's that. I would literally just copy and paste this into your report, into your paper. Except I'd get rid of these two columns that nobody knows what to do with. MSV and Max R. Don't worry about those. Another one we can look at is plugins model fit. See if it works. Wow, it worked. Cool. It should produce all the model fit measures you're concerned with and interpret them for you and give you advice if there are problems. So the C-min over DF should be between 1 and 3 or 2 and 5, depending on how you look at it. So that's excellent. CFI should be greater than 0.95, but it's acceptable at greater than 0.9, whatever that was, acceptable. And then SRMR, which I need to show you how to calculate, should be less than 0.08, which is great. RMIT, less than 0.06, it's great. And be close, greater than 0.05. Here's what you actually observed. Here's the threshold. Here's the interpretation. And here's the cutoff criteria, how we decided that. And also some references for how to do it. So this should simplify your model testing a lot. Has anyone ever done a CFA and like done this for real? Like, yeah? It took forever, right? You press a button, it takes 3 seconds. Yay! So I took these classes, I was taking these classes on SEM, and I couldn't handle the hour or 2 or 5 hours it would take me to do all these analyses. And then find out when I was done, I'd find out, oh, I had poor on one of the model fit measures. So I could go back and do it all over again. And then I'd have poor again, or I'd have a discriminant validity issue, and you're gonna do it all over again and take another 5 hours. Ain't nobody got time for that. So, anyway, plugins. Automate things that should be automated. But that's why we're making the EFA automation tool, because I mean that would just solve hours and hours and hours of time. Okay. Okay. So that's the first step. Establish a roughly valid, roughly good fitting model. And once you've done that, it's time to move on to the next step. How are we doing? It's right after lunch. I know right after lunch there's always a little bit of antsiness and tiredness. Do you need a 2-minute or are you good? Let's take 2 minutes, real quick. Let's take 2 minutes. I know after lunch it's tricky.
Excellent plugins.
Those plugins make miracles, yeah. Miracles happen. I sent them to Amos and they said, meh.
Is it a problem if I run CFA separate from DI and DB and IB?
So I would strongly recommend you run them together because we need to confirm that they are discriminate from each other. There will be literature that says you should run them apart as well.
Yeah.
But I disagree with that literature.
Must run together.
Most you run together. Yeah.
Until got the design model fitness.
No, always run them together.
Yeah, I got one. I got the problem. I run the DB separate. All good. But when I put them together, I got a problem.
So, and that it's good to know because if it has a discriminant validity issue, then you can't make a causal analysis and make any confident findings from it.
I mean, when I put in the structural, in SEM, all good. But I just get stuck in this.
In the CFA, you get stuck.
Yeah. Of the IB, if I put IB separate, because I got like I think more than one IB, like 2 or 3 IB.
Yeah.
It's all good. Everything good. Just combine and close together.
And it causes a problem.
Yeah.
It really should be together. It really should be. You can, if it won't work, you can always cite the literature that says it should be apart.
Yeah.
You
So
could.
that's, I know it's not right, right from watching your video, but I don't know.
So, did it work in the EFA?
I think it worked. I think the point is quite when I put it together, it's too correlated.
It's too correlated, yeah.
So too close together.
And that's what I'm saying. That you need to separate them so that you know that you're measuring, you're predicting something not with itself. Yeah, because if it's too closely related to each other, then you're predicting something with itself, which is tautological. That's why you need to test them together so you
But
can
the
separate
theory,
them.
everything is fine. It's just put them together and then
Yeah. Sorry.
thank
That's
you.
a quick one.
Yeah.
So for presents, right? Whenever we do that, all together.
Yep. All together.
If it doesn't matter first or second order.
These second order each.
Yeah.
So let me show you second order right when we come back.
Okay, so you have to do it separately.
No, you do it together in CFA.
Oh, so I build here and I add another level.
Yes. So I'll show you.
Okay, great. This is the same in my life.
Yeah, good, good.
So we can actually use the plugin also for second order.
We're working on it.
Okay.
Yeah, we're working on it. But there's
I'm greedy now.
no, you're fine. But there's a tool that will let you do it. My Excel tools will let you do it for second order.
Okay.
Yeah, so I'll show you that.
Show me that view also. Thank you.
Yeah.
Like if this has so
Oh,
then
yeah. So let's set them both to 1. Set them both to A.
we have to set them to A.
Yeah. 1 is something very different. 1 is an actual number, whereas A A tells it to be equal to each other. 1 says just anchor it.
Yes.
You can. Yes. Yeah. So did constraining to 1 work?
So if
No, you don't need to change all the others.
but if I constrain them to the same value as A,
Yeah.
then I have to
Then what you have to do is put a variance constraint on its latent like that. Yeah. Now it'll
and for the order,
don't need to change anything. Although we have already pushed the variance constraint out to here. Instead of leaving it on the indicator, I put them out just to get here. You see I put all the constraints here instead. Yeah. It's for subsequent analysis. One thing we're going to do later requires the variance constraint to be out there, so I just moved it.
So there is two ways. One way is to constrain them to A and put it as 1. And the other way is to constrain them to 1 as well.
Did it work? Did you try that? I've never tried that. So I don't know if it worked.
You mean number 1?
Constrain the book to 1.
Okay, let's see.
Oops. Just single click on it. Just single. Yeah.
Yes. Because I'm seeing maybe.
Oh, no, you missed it. There you go. Yeah. So
Because
right.
it's.
Right there.
Yes, sorry.
Yes. It did run. Cool.
It's run.
But did it work? So hit the up. And
Yeah,
it worked.
it's the same.
Cool. Okay, good.
Yeah.
Good.
Thank you.
Yeah. Yeah.
Use different items from different scale to make like a scale.
Yeah. If it makes sense theoretically.
Yeah, theoretically it makes sense, but is there any statistical issue like so it's much more
No, as long as they have the same scale size, like 5-point scale, 7-point scale.
Let's say relationship is important. Yeah, so they have many people with different sort of skills for that. So I use like 2 items from one skill makes sense to me, and 2 from another skill. Is that okay?
So it's okay. What you'll often find that will separate in the end. So that a bit.
And then
If it separates, you might have to set them as 2 dimensions of a higher order.
the second one,
And we'll do that in just a second.
if it comes into the same then no problem. So editors understand is or it take different.
They might.
Okay. But statistically it's not.
No, statistically it's fine. And then that we use the argument. Say it makes more sense. It's capturing the traits.
Okay, so do I need to justify it using anything else like if I using EFA or any other treatments?
Oh yeah, just show it's a language. Show that
This way. All right.
With the AMOS, so it's mainly reflective constructs
all reflected. Cannot be formed.
Yeah, because I was trying to get the plugin. I was just checking to see if you're gonna save the file, this file, and
Oh, do you want me to save it?
yeah,
Yeah, we can save it.
because
There we go. It's saved.
in the RMIT.
Yep. In
Yep.
Amos folder.
Yeah, okay, that'll be good because the plugin is there's some issues with the plugin.
Okay. Yeah, it
Yeah.
doesn't always work.
Yeah.
Yeah.
And is there any scenarios where you should use, like you said with SPS, not SPSS, PLS, it has to be complex large samples.
It
So
doesn't have to be. The only real strict requirement is formative factors. If you have formative factors, you may not use Amos.
yeah, because for example, for my PhD, the construct has both reflected and formative. So that's PLS here. So for this, it's just reflected.
Only reflect.
Oh, no worries. Yeah, thank you.
The rush model? Oh, the rush model. No, I don't. Yeah, sure. I'll be around. We can chat. I don't know if I'll have answers, but I'll try. Okay. Yeah. Hello. Great. That's why I'm here. Did you use PLS consistent?
Yeah.
So in your method, you use PLS algorithm for this work. Thank you. Is it all reflective? Didn't we have this problem yesterday also? You had this values. Maybe someone else. Let me just try consistently. When it doesn't work, try another one. Well, just report the RMR then. Yes, RMR. Yeah, even though it's not good. Yeah, not applicable. Yeah. Maybe it's it didn't run it. I don't know why it didn't run it. Maybe it's because it has formative measures. Maybe you can't have all of those formative measures. I can try it. Thinking. Yeah. Let me switch one around. Let me make it formative. Okay, now it's formative. Let's see for sure. Oh, no. Okay, now it's formative. I'm using also path.
Yeah.
I don't know. Yeah. I honestly don't know.
So is any serious problem with the model?
I doubt it. Let me try one more thing. Yours is an independent exogenous variable, yeah? It's formative. So let me try it that way. Because maybe that's the issue. Nope, not the issue. So I don't know why you should be doing that. Unless you have missing data, maybe NFI can't be calculated with missing data. Do you have any missing data? No. Okay. I don't know. Or maybe it's because you have infinite chi-square. What's your sample size? 300. It's not too complex. I mean, it's fairly complex, but not too complex. Do you have a repeated indicator in your second order? That was repeated. Okay. But it's
So I use selected variables.
yeah, try that. Just for that one.
Yeah.
That might fix it.
And I would like to ask you, with the PLS, the measurement model, the step to measure the model is CFA. I mean that everything that you
it's
measure.
confirmatory. Yeah, it's not exploratory.
Yeah. That's use the yesterday.
Yeah.
Everything is the CFA in PLS. Thank you so much.
Yeah. Okay, let's get started again. We were going to do a couple things. Second order. And another thing. Okay, every time we have these breaks, there are a bunch of things that end up cropping up. Two things. First, let's deal with second order factors. Let's pretend we have a second order factor here in usefulness. How would we model that? From your pattern matrix, you wouldn't have been able to import that pattern matrix just like that. So what we'll do, I'm just going to sort of create a hypothetical second order factor here with usefuls. What you do is you click on this ellipse thingy, and then over here, create a new ellipse. Sorry, say again? Items 7 and 8. Oh, down here, the social desirability? We can play with those. Let's do those, sure. I'll do it down there. It'll cause a few issues, but it's fine. But you're right, they are part of a second order factor. Problem is, one's in one direction, one's in the other direction. So I'd have to reverse them. I'm actually going to do it up top. It'll cause fewer problems for this particular issue that we're dealing with. But yeah, you're essentially right. They are part of a second order factor. But to make them work in a reflective scale, we'd have to change the direction, re-reverse them. Okay, so you include a new ellipse. Oh, by the way, I moved it around with the fire truck, obviously. That is how you move things. It's with a fire truck. I don't know why. Okay. Are your fire trucks right here? Okay. The next thing we need to do is create one more ellipse. Oops. One more ellipse. Okay. And I'm going to just move some of these regressions over. And again, I'm just making this up at this point. This isn't really a second order factor. It's just for the sake of teaching. Let's say you had two factors that were highly correlated, right? If I were to correlate these and run them. Oh, how do I drag the arrow? Sorry, I didn't show you. With the fire truck, you can drag an arrow. Of course. So intuitive. Okay. Once you have, let me zoom in here. Once you have that, what you can do, let's name this something else. This is usefuls B or something like that. Text usefuls B. I'm assuming nobody's actually like doing this with me, right? You're just watching, or you're actually doing it? Oh, okay. Never mind. Okay. We'll do it. Okay. So I'll go slower. That was really large text. Wow. So, going too fast?
No.
Okay. Click on X marks the spot, this X here. And we're going to delete the covariances. Actually, makes more sense not to do that. Use the fire truck. We're going to drag the covariances out to here. Okay. Once you do that, let's name this new higher order factor to useful daddy, or whatever it's going to be called. And then you have to draw with a single regression line, single-headed arrow, single arrow-headed regression line from useful daddy. Click and drag to, oh, it's going to throw you an error. Here's why. There's a variance constraint on usefuls right now. We can't have a variance constraint on something we're predicting. So I got to get rid of that by double-clicking, go to its parameter, delete the variance constraint. And instead, let's put it in useful daddy. So variance constraint on useful daddy. Sorry about the name. Okay, now we can draw a single-headed regression arrow from useful daddy to usefuls and usefuls B. And we can also use our magic wand to make it all pretty. There's a magic wand. Click on useful daddy. There we go. That's prettier. Okay, this hopefully should work. What this does is it just treats these first orders as the indicators for the second order. Notice we don't have to use a repeated indicator approach here. In Amos, that's not a requirement. It just assumes as indicators the factors themselves. And the way we would validate it is similar to the way we would validate a first order factor. First, let's try running it. Does it run? Oh, nope, it says here's an error. It says you need error on anything you're predicting. So let's add some error. This little box with a head is an error applicator. So you click on it and then click on these two things and they get error. You have to name that error. So many little steps. Plugins, name unobserved variables. Now we'll name them E41 and 42, hopefully, or whatever the next error number is. And now it should run. Hey, it ran. Or it's running. Nope, it broke. Okay, it did not fully run. It said it reached one iteration and stopped. So that's no good. Here's why, probably. We got to move the variance constraint from the latent factor to one of these guys. Put it on a regression weight. How on earth would you remember all this stuff? Watch videos. Don't remember, just watch the videos. Or do it every day and teach it. I'm going to run it again. Yeah, I'm going to save. Save. Please save. Close. Reopen. Amos. Run again. What? Oh my goodness. I hate Amos. Can you believe it's actually the best software out there? Okay. I'm going to make sure it's actually closed here. Yep, Amos is actually closed. Good. Okay. Okay, opening it back up. Oh, did it work for some of you guys? No, also threw you an error? Great.
Just the revision one, still the same.
Okay. Let's try this again. Oh, I know why it didn't work. Sorry. Okay. Sorry. Those two factors at the top, usefuls and usefuls B, they also need an indicator constraint. So double click one of those indicator constraints, parameter 1, and another one on the other one, 1. So it looks something like that. Top. So we unfortunately we couldn't put it in the factor because it's being predicted, and so you can't fix its variance because it is being predicted. Okay, hopefully that works. Save, run, an error occurred. Amos output file is missing. Oh my goodness. Did it run for you? Oh good. I'm going to be happy with that. What were the path loadings from daddy to first order? Yeah, very high. 0.99, 0.93.
0.93.
Good, good. I'm so glad it worked for everybody except me. All right. I'm going to close that. Ooh.
So,
Yes.
can you open it like one again?
Yes, I will in a moment. I'm going to go fix the issue it's giving me. That should fix it. I need permission to delete that?
Yeah.
James, just quick question.
Yes, what?
Does it matter here, reflective or formative, does it?
In Amos, you must have reflective factors. You may not have formative factors in Amos. Back to the drawing board.
You can average. If you want to use, if you want to run formative construct, you can average them and run it in the Amos.
All right, I have a workaround. Okay. Mine's having this nice error where it won't let me automatically delete the diagram file. So here, the output file, I'm going to just change this real quick. RMIT, CFA, second order. Okay. Okay. That should work. Yep, there we go. It worked. Okay. So as you can see, Useful Daddy has strong loadings, as we would expect on a reflective second order factor. And as lower order factors have strong loadings, how would you validate this? You would actually validate it at the higher order level. And you say, oh, the ABE here is more than 0.5. For sure, the CR is more than 0.7. And we could actually do that. I doubt we could do it with the plugin. We can try it and see if we fail. Master validity. Yep, it says no good. But what you could do is do it in the stats tools package, my Excel tools. So for those for whom this doesn't work, what you do is you go back to the stat wiki, go to the home page, and get the stats tools in Excel, which is just on this home page here. It's called stats tools package. If you open that up, just click on it and then open it up. It's opening. Here we go. Make sure to enable content and enable macros if it asks you to enable macros. And on this first tab, the Validity Master, it does the same thing as the plugin, but it can handle second order factors. So the way you use it is you go to the output, which is next to the floppy disk. Go to the estimates, scalars, correlations, and there's a video on how to do all this. Copy this table by clicking to the right of it, and then right-clicking and copying it, sticking it in A2, and there are instructions right there, paste correlations in A2. Then you paste the standardized regression weights in F2. So go back here, get standardized regression weights, same thing, copy the table. Paste it in there. And then if you click on this button, it'll do it for you. It will do it for the second order as well. So here's the first, let's see, decision, where'd it go? Useful Daddy. Useful Daddy is right here, second order. It produces CR and an ABE for Useful Daddy. And its correlation matrix, square root of the ABE, and cross correlations. So we can validate it that way. Okay. We're trying to get so this is the same as the plugin, except this works for second order factors, whereas the plugin doesn't yet work for it. And my research assistant's working on that right now, trying to fix it. So it'll work for second order factors. Okay. Yeah.
You said that in the EFA, if we have the second order factor, so we do EFA twice, one for the dependent variable with the second order, and the other with the second one with the rest. So when we do something like this in EFA, how can we continue in CFA?
Okay, so if you ran multiple EFAs, how do you continue in the CFA? The thing is, you'd have to build it manually in the CFA. Or I think there's a new feature in Amos. Let me see if I can do this. Excuse me. I think I can have two models open at the same time. Let me try this. So I'm going to open up Amos twice. And I think I can copy the entire model with the fax machine. Nope. This clipboard thingy. Clipboard. Go over here, and I think I can, I can paste the model in there. So what I could do is I could create with the plugin all these different models for my different EFAs, and then copy and paste them into the same Amos file. And then you have to covary all of them. Yeah. You should include all of your latent variables in your CFA. So both your DVs or all of your DVs. There should be no duplication of items, yeah? Oh, if you, okay, yeah. If you're running multiple EFAs, and there are overlapping items in the EFA, yeah, when you paste it in here, there's gonna be duplicates. So get rid of all the duplicate factors. Oh, it won't make a difference as long as you get them all in there. Whatever the easiest way is for you, as long as they're all in there, it won't make a difference in the CFA because the CFA reruns all the statistics. So as long as there's not duplication in the CFA, however you get them in there is fine. Huh?
Back to the question on so you can't use formative variables in AMOS. So
Yeah, you cannot use formative in AMOS.
So how do you do CFA with formative variables if you're not doing SEM as the next step? So rather than doing, can you just do factor analysis in PLS and then do other?
Yes, you can do factor analysis in PLS, but which is what we did yesterday. We did some of that. If then you wanted to test your model in, is that what, test your model in AMOS?
So like use other stuff like completely different.
Oh, yeah, you could do your factor analysis in, the thing is, yeah, so you can do your factor analysis in PLS, and then you can take factor scores from that and analyze them in any other software you want. Yes, that's the short answer. Okay. All right. We were here. We obtained a roughly good model. And the next thing we have to do is invariance. Here we go, confirmatory factor analysis. Next thing is to do invariance. Okay. There is an easier way to do this now. Another sort of plugin. Invariance, I should explain what invariance is. We talked about it yesterday briefly, super briefly with PLS. Invariance is whenever we have a multi-group comparison, and in this model we are doing a multi-group comparison. You may recall we're doing multi-group across gender. So we're saying there are two groups in our data. One is male, one is female. And we expect them to be different at the structural level. We expect that the hypotheses in our model will be different, at least the causal paths will be different based on whether you're male or female. We found out yesterday in PLS we were wrong, but at least we're trying it. Okay, so anytime you say there's going to be a structural difference across groups, you need to demonstrate that there is not a measurement difference across groups. So that's called an invariance test, a measurement invariance test. And it's a prerequisite to any multi-group analysis.
Particularly when it comes to comparing between countries.
Yeah.
Particularly in the international marketing literature or anything to do with that, they particularly ask for that test.
And in comparing industries,
yes.
And in comparing job categories, yeah, all that stuff. Anytime where there's potentially a real difference in the way people would answer your survey, you need a test for invariance. So the way to do that, there are a couple ways to do that. One is called configural invariance. And to test for configural invariance, all we have to do is set up the groups. So let's do that. First off, should we use the second order model or go back to first order? Or just leave it at second order? Okay. First off, let's save this as something else. Save as RMIT, CFA, invariance, something like that. So now we have something we can go back to without groups. What you have to do is double click on group number 1 and rename it to male, and then click new and rename group number 2 female, and then hit close. If you accidentally hit new and it created a group number 3, just double click group number 3 and hit delete and close. So you need 2 groups up here, male and female. You can have as many groups as you want. Just know you can only compare 2 things at once in your brain. So we have male and female. We need to add data to each of those. So you go to the data files button next to the colored abacus. We already have data in our male group. Let's give data to our female group. So double click the female group. And you'll find that data. It's just the MC trimmed. And notice the N for both of these is 378. We need to adjust it so it's filtering out anyone who's male or female in the right group. So for the male group, we're going to click on grouping variable, select gender, which if you just click over here and hit G, it'll jump down to gender. Hit OK. And the female group, grouping variable, gender. So they both say gender. For the male group, the group value is 1, 287 males. Okay. For female, the group value is 2, 91 females. And now your N should be correct. 287 and 91. Did I go too fast? A little bit. So again, make sure you have data for both. Then click on grouping value. Select the gender, and then grouping variable, select gender, grouping value 1 or 2. We're good, good, good? Good. Okay. And now we can compare these two models. We're just going to run it so you can see what's going on here. Just hit run. And it's going to take a little bit longer to run. Hit the up arrow. And what we have is, over here, we have the two groups. We can toggle between them. When we toggle between them, let me zoom out, you'll notice that the values change ever so slightly. Maybe that's a subtle change. It's hard to see up on the screen. But they change ever so slightly. So these are the different runs for the different groups. This male group, the model was only estimated for those with a male identifier, and female was only measured for a female identifier. So now, the question is, do we have good fit? If we've separated these two models, even though they're two separate groups, the model will estimate model fit only once because it's the same model. It's not a different model for both groups. It's the same model. We've just separated the data. And so if we look at the model fit for this separated groups and the model fit is good, then that is an indication that separating them is okay. We have configural invariance. Yeah.
So we do the invariance test only at the CFA level.
Yes, just at the CFA.
When we go to the structural model, it becomes modeling then.
Yeah, in the structural model, it's still, I mean, technically it's an invariance test, but it's, we want the opposite result.
Yeah.
In this invariance test, we want to see no difference.
Yeah.
In the structural invariance test, we want to see a difference. Yeah.
Okay.
Yeah. So
when we write the paper, we have to show both.
We do have to show both.
Yeah.
And this is called measurement invariance. The other one would be structural invariance or multi-group analysis. Yeah. Okay. So what we do is we just look at the model fit. Or we can click on the plugins. Plugins, model fit. And see if model fit is good. Model fit would have changed slightly from what we had before. It's thinking. Oh, there we go. And the answer is yes, our model fit is still good. So we have configural invariance. More often than not, this will be fine. I've almost never, maybe never, have I seen not configural invariance. So I wouldn't worry too much about this one. The harder one to achieve is metric invariance. By the way, if you didn't achieve configural invariance, then that means there's some item or two, or maybe a whole factor, that your two groups interpreted very differently. That is possible. And in that case, you have to figure out which factor or item it was by looking at this. Go to the output. Go to the estimates, scalars, standardized regression weights. And then what we're going to do is we're going to look at this while toggling between male and female. And you'd find the ones that were really different. You could actually just copy this out into Excel and look at the difference, right? And see which one was biggest. And so if you didn't have configural invariance, maybe there's some item over here that changes from like a 0.9 to a 0.4. That's the problem. You may end up having to either delete or constrain that item.
Is there a rule? Like
in configurable invariance, is there a rule on the amount of difference?
yeah.
No, it's just, did you have good model fit? If so, we're good. Yeah. There is a rule later on metric, though, so we'll do that. Okay, so we're configurably invariant. We do have to mention that when we're doing our measurement invariance test. The next step is to do a metric invariance test, which is not a lot of fun, but there's an easy way to do it now. Go ahead and save your model again, just so we have that. And what we want to do is use this feature, which makes life way easier. There's this thing, it's like groups button. Click on that. And you'll see a warning. Yes, go ahead and hit OK. I hope it works with the things we have going on down there. We'll see. Go ahead and just accept all the defaults. It's going to pop up this thing that says, here are all the models we're going to create. It's actually going to create 5 models with all these different constraints. That's fine. Don't worry about it. Just hit OK. And notice over here, it created 5 new models. We have the unconstrained model. That's what we were dealing with before. We have a model where the measurement weights are constrained to be equal. One where the structural weights are constrained to be equal. Covariances, residuals. Some of you may have heard of scalar invariance, intercept invariance. There's several of them. We're not going to test all of them. We're just going to test metric invariance, which would be, we'll see. Oh, one more thing I should show you. Notice also everything got named. The covariances got named, the weights got named, and they're different across groups. If you were to go between male and female, male is all _2, or female is, male is _1. So everything has a name, which allows Amos to do things like this. For example, if you were to double click on measurement weights here, it allows Amos to do this. Say when you run your measurement weights model of those 6 models, make sure that A14 _1 is the same or is equal to, constrained to be equal to, A14 _2. What does this mean? That path that was named this, for males and for females, we're forcing it to be equal. We're constraining them to be equal. What we're going to do is we're going to run a chi-square difference test, which is a test of difference in model fit. And it's going to say when all the regression weights are forced to be equal, what is our chi-square? Is it inflated or is it normal? And compare that to when they're not forced to be equal. Is the difference between those 2 models big or not? If it's big, then that means males and females are not the same. Because when they're constrained to be equal, it's not the same as when they're unconstrained. These models are different, meaning they're invariant, which is actually not good at the measurement level. If that didn't make sense, just know that that didn't make sense to me for the first 5 times I was taught it. And we'll do a few more of these invariance tests, and hopefully the 5th time it'll make more sense. If it did make sense, you're a genius. Okay. So good for you. We don't want to keep all of these right now, although we don't care that much. Let's just leave them for now. Hit close. We have all these models to run. Go ahead and just hit run. It's going to think for a sec. There's a lot of models to run. Good. Okay. Go to the output. And in the output, we have a new section called model comparison. Excuse me. This is the original model. Let me pull this over. There we go. With all of its chi-square difference tests. I should just zoom in. Okay. We want this p-value column to be filled with non-significant p-values. That would mean we have scalar invariance, metric invariance, intercept invariance, all those other invariances, residual invariance, error invariance. If they're not significant, that means that the two models, the constrained model and the unconstrained model, are the same, which means males and females are the same with regards to these different measures. And so we're good, actually. This is the only one that gives us trouble. I'm not worried about this one. Nobody has ever in my life of publishing asked me to do a residual invariance test. So maybe it's because I'm not publishing as much in marketing. Maybe they ask you to do that. If they do, there it is. Anyway, so we're good. Males and females are the same. If we weren't good, what would you have to do? I'll show you. Don't follow along. Just watch for a sec. If we weren't good, if one of these was like 0.03, what we'd have to do is go find out which paths were giving us the problem. Because right now, this is assessing the entire model together. So which paths are the ones that are really causing the trouble? I'd have to go here to estimates, scalars, and I'd go to regression weights, not standardized in this case. I'd copy this table over to Excel. And then I do the same for female. I could toggle over here to male, female. Go grab this table, copy, paste it in here. And then I want to compare the estimates from one to the other. And get these ones here, copy. Paste it here, paste. Get rid of this stuff, don't need that. Okay, so I'm just going to compare. This is female, male. I'm going to call this delta equals this minus this. And I want to see where the biggest differences are. Okay. Let me format that so it's easier to read. And the answer is 0.1, 0.132, 0.15, 0.181, 161. These two right here, and 184. Oh, 2-1. Here's the big problem. This is the path right here, social desirability 2. That's the one. And if I wanted to go test it, here's what I could do. Go back to Amos. And in Amos, oh, there's a lot of stuff going on here. Let's, for the sake of simplicity, I'm going to delete a few of these models. Just trust me on this one. Delete, close, delete, close. Okay, we're just going to work with this one here. So we have all of these. We have all of these things constrained to equal. Let's go find the path that was causing us the problem. It was social desirability. Which one? All right, zoom out. It was social desirability 2, which in our model is called A34. Nope, A33. So I would go take all of these except A33. And I would just constrain A33 to be equal across male and female. Everything else can be unconstrained. If I get a bad invariance here, then I know that is the path that's causing the troubles. So close it, run it. Model comparisons, there's that p-value. Sure enough, that's the one causing me the problem, is that path. It's moderately significant. We don't want it to be significant. We're only constraining one path and it's causing a problem. That's a problem. So what would we do? Either we could just constrain, leave everything else constrained, leave this unconstrained, and just say we're partially invariant, right? Except with regards to this item. Or if it is redundant, take it out. In this case, it's not redundant, so we'd have to leave it in. Okay, all of that so you can do multi-group comparisons later. And reviewers will ask you to do that, particularly in the marketing field, where measurement invariance is a big deal. Okay, let's take a 2-minute break and come back to the next step. But that's all of invariance for measurement level. Hello. Yes.
This one and that.
Yes, hit OK. You have to enable macros. So on this. And enable this content. There we go.
Hey, cool.
With the second order. Yeah. Yeah, because we expect the first order factors to be very correlated. So it's going to be very hard to establish discriminability between them. The second order factor they're actually doing causal analyses with. And so in terms of tautology, that's the only one we're interested in. Yeah.
Just on the front. Just on this one. It's right, I think. Yeah. No, like the address is 2. This one is a full model.
That's great. 968, RMIT. There we go. That's great. Fabulous.
But one friend told me that when I tried to fix
Yes, Armor.
which I was actually supposed to ask you tomorrow because it's no session I get. No, because you mentioned that it is, I think it is like less than 0.8, but it's like 0.1.
0.01?
Yeah, 0.01. But he said that if it's like all instructional model is almost impossible to get that kind of thing unless we have.
Wait, oh, you have a 0.1. Oh. So one reason that might be is because you have a very exogenous variables.
But the hypothesis like
So AMOS assumes you're going to covary the exogenous variables, and so regardless of your hypothesis, they should be covaried. Yeah.
I've done that much more. It should be second. But this one, like you say that it should be greater than like we can achieve this kind of session. That's very something.
Okay, that doesn't make sense to me, but if it were me, I would covary those exogenous variables, and that should probably be true.
I didn't read.
That's all right. Did it work?
Yeah.
Cool, it actually was.
But I can see that because two of my so I can see which dimension before 3D of the I can see which items maybe should be here.
You can. Yeah, you can do this before the CFA if you want. Is that what you're asking?
Yeah.
That would make life easier.
Yeah.
With a model this big, it would make life easier.
Because I can see these are all vertices. They're all for
Yeah. Yeah, see, it's cross-loading. Yeah. So what you would do is actually build it the way it makes sense theoretically. Ignore the pattern features for now. Just build it the way it should be in the CFA. Clean the CFA, and then if you want to go back to the PLS. Or if you don't want to, don't. Yeah, as long as you have good model fit and validities, you're good. Yeah. Yeah.
So I'm just trying to
Oh yeah, yeah. This file is okay. Yeah, what you're gonna do is you're gonna right click it and download, and then don't click on it. Yeah, so save as whatever.
save it.
Yeah, save it. Okay, and you go to that location. Okay, so then right click it, not that one. So now we want to put it in the correct folder. Do you know how to get to that folder?
I'll follow the steps.
Okay, okay. Sounds good.
Once you get story, yeah, sure. Then you have to bring the water back. Yeah. It's all water.
Then when we finish, we also look for the independent variables and the dependent variable with the first order.
I don't think I understand your question. Did you draw it? Did that help?
Just like, just like,
Okay.
firstly, we looking for the independent variable to the useful maybe. And then we also to the
No. So in your causal model, no, you'll only deal with this. You don't even bother with customers. They're just indicators. They're just indicators for most of that. So when you're drawing your causal lines, your line will draw from here to there, not to the first one.
so in the CFA.
Right, in the causal model, right? Yeah. That's what I'm saying. In the causal model, you don't even deal with the first order.
In the actually, you understand from similar to high what is supply chain. Firstly, we test the impact between the independent variable, the first order factors, and then we also test the impact between the independent and the second order.
So you can do that, and I've seen also when they do that, and it's to show that it's robust, yeah, and also to show that the second order model is valid. Yeah, so you can do both, but really to test your theory, you need to do it to the second order, not just the second one. Yeah. But reviewers may ask for both as a robustness test.
Thank you very much.
Yeah. Okay. Okay. Okay, let's get started again. So we finished invariance, which is arguably the most painful part of the whole process, except maybe method bias. That's also painful. So what we want to do, now that we've established we have configurable and metric invariance here, we don't need to keep our models separate. or our groups separate. We're actually just going to save this and go back to our model where there was only one group. This one. So only one group. To get to that point, just open up the other one. You can close the multi-grouped one, open up the one that was just one group. Okay. The next step is on the guidelines page would be a validity and reliability check. Actually, we just did this. We don't need to do it again because we didn't change anything. So we're still good. So the next is very painful, method bias, or what we might call a specific bias. So the method for, let me go back, method bias. Most of you are probably familiar with this. Some of you may not. So for the sake of those who are not familiar with method bias, the language and literature around method bias has been changing constantly. It used to be just shared variance or method variance. Then we called it common method bias because it's, well, I should define it. Method bias is the piece of your measures. It's the variance in your measures that cannot be attributed to error or to the trait itself. It's the part of the measures that is either inflated or deflated based on some specific biasing influence. For example, yesterday we talked about loyalty to your organization. You're going to inflate all your responses. Or if you're not loyal to your organization, or if you're burnt out, you're going to deflate all your responses. If you're being asked about crime or corruption, you're going to definitely suppress how you respond to those. You're going to answer them in a very socially desirable way. So method bias is a way to identify and extract or parcel out the variance attributable to response bias. Now, the way to do that has changed a lot over the years. There are multiple ways, and if you look at the StatWiki, I actually list 4 different ways. I met with Jagdeep Singh. He's some of you in marketing might know Jagdeep Singh, actually. Yeah, he's a very well-written. He's a great senior scholar. He and I work together at Case Western Reserve University when I teach out there every few weeks when I teach their executives. So he and I sat down together at the top of the Himalayas in Cleveland, and we sort of duked it out over method bias. And he knows what he's talking about. We worked it out on the board. I revalidated it with him. I sent him a step-by-step and said, is this right? And he said, no, you didn't understand. We did it again. Finally, we got to an agreement on how to assess method bias correctly. We should probably write a paper together on how to do it. But I'm going to make a video on it as soon as I get home. Because we just barely figured it out, and then I lost my voice, and I couldn't make any videos. And then I came here, and obviously I'm still sort of losing my voice. So I'll make a video as soon as I'm done with this conference. We'll make a video, and we have a video being recorded right now on how to do it correctly. But because I just barely figured out the correct-ish way to do it, I may be referring to some notes. Here we go. But if you want to know the correct way to do it, it's also here in the StatWiki. If you go to CFA, in fact, everything we do is in the CFA section today. If you go to method bias, section 3, and go to the 0 and equal constraints, here's a step-by-step way to do it. Oh, and we should find out if John finished. My research assistant, John, was making a plugin to do it automatically because it's so many steps. And he was almost done. He was actually done yesterday, and then we looked at it and there was an error. So he's fixing it today. Let's see. Well, we'll see if we get email about it. He was going to send me an email with the plugin, see if it worked. If not, we'll do it step by step. Here we go. So to start off, we only now refer to specific bias. Some of you may in the past have used a common latent factor, an unmeasured latent factor as advocated by Podsakoff and McKinsey and others. Some of you may have no clue what I'm talking about. That's cool too. But if you've done method bias before, You may have used that approach. You may have watched my video and done that approach because I advocate that approach. That's no longer good. That's not an adequate way to do it. What you need to do when you're designing your survey is you need to identify a potential specific bias. So if you're asking about corruption, ask about social desirability bias. If you're asking about firm performance and firm innovation, ask about organizational loyalty. If you're asking about personal, individual performance, ask about self-efficacy and optimism, things like that. Specific sources of bias that could inflate all the responses in your survey. And so you include that in your survey design, and then when you do your EFA, you include those specific bias variables like we did. We included social desirability. And then you do your CFA with the social desirability, with the specific bias variables in the CFA, which we just finished. And then you need to make sure you have good fit and reliability, adequate reliability, the key word there, adequate on those specific bias variables. We have adequate, it's not great, but it's adequate. Next, we're going to do number 3. We're going to do the hard part, which I wish I had the plug-in for. Let's see if he sent it. John, nope. Oh, that's too bad. Okay, we're gonna do it the hard way. You're welcome to do it with me or just watch. It is going to be slightly painful with this massive model. Here we go. How many are gonna do it with me? How many are just gonna, who's just gonna do it with me? Really? Okay, I'll go the right pace. Okay. So click on X marks the spot. It's the deleting thing. Zoom in down here. You can just scroll. That's how you zoom in Amos. Okay. What we need to do is we need to disconnect our specific bias markers, variables. That's social desirability, positive and negative. We need to disconnect them from the rest of the CFA. To do that, get rid of the covariance arrows by using X marks the spot. There we go. So they should be disconnected. If you accidentally click too fast, it'll double click and create an object properties window. Close that, delete some more. Next, use the open hand right here to select everything. It all turns blue. Use the fire truck to move everything over. So we just have some room here. And then use the closed hand to deselect everything. Next, see these balloons? They're not balloons. They preserve symmetries. They make it so you can move a whole factor at the same time. Click on that balloons thing. Make sure you still have the truck selected. And then go down here and move your specific bias markers or variables. We shouldn't call them markers. Specific bias variables over here. Just move them up. What we're going to do, we're moving them to a place where we can relate them to everything. Next, the hard part. The unfortunate part. Well, here, easy part first. Click on the double-headed arrow and covary these two factors. You might just have one. You might have 5. You might have none. Hopefully you have at least one you've collected. More often than not, you'll only have one specific bias variable. We have 2, so let's covary them. Okay. Next is the hard part. What you got to do is draw a line, a single-headed arrow, to every observed variable in the model, except to their specific biases they're already connected to. Yeah. For the sake of today, let's do this. Let's delete the negative social desirability one, because that doubles what we have to do here. So I'm just going to delete this one. If we had the plugin, that would have been fine, but whoa. Okay, single-headed arrow. You can fast forward me or put me in 2 times speed in YouTube. Can't do that here. You ever take those classes where you're listening to your professor on a video, you speed them up, and then when you see him in person, you're like, come on, talk a little faster. You talk so slow. Okay, don't miss one. So this is what the plugin does. It automatically creates all these arrows and labels them as we need to next, unfortunately. But there's a shortcut for that too. Can you imagine doing this if your model was twice this size? Ooh. So I should tell you a story sometime about how I moved away from home as a child. I left home, moved to Hollywood, got kicked out of high school, never had any plans to go to college, pursued a career in performance, was almost Spider-Man, like for real. That's not a joke. It was me and Tobey Maguire, and they went with Tobey, which is great. He did a good job in the first one. Okay, those are connected. Okay. Also met Pink, did a music video with her. She's nice. And a few others. Okay, so you just need to connect them. I made them pretty by using the magic wand. We can use the truck to move it out, so we can, oh, let's not use the truck, or not use the balloons. Just move it individually, there we go. Okay. What we need to do, what we did do and why we did it. Let me say that first. What we did was we connected social desirability bias to every item in the survey. Why did we do that? Here's why. We're theorizing, measurement-wise, we're theorizing that there's some response bias in our data that can be explained by social desirability bias. And by connecting them, what we're saying is that social desirability bias, as represented by these 3 items, shares something with all of them. Yeah? And by connecting them, we're able to pull out that bias to some extent. Now what we're going to do is we're going to run a couple tests. The first test we're going to run is unconstrained. We're going to say we're just going to pull it out, see how it works. The next test we're going to run is we're going to constrain all of these paths to be 0. What does that imply? It implies that there is no bias. If we compare that unconstrained model to a 0 constrained model, that's seeing if a no bias versus a maybe bias is the same. If it is the same, we have no bias. If it is not the same, we have bias that is different from 0. Once we do that, we'll do some more tests. So let's run this and pray and hope it doesn't break. I'm going to save as first. RMIT, CFA, CMB. Can't call that anymore. SP, specific bias. The word common method bias isn't preferred now. It's specific bias. Okay. Run this. Please run. It's going to throw you an error. That's fine. It says that you haven't covaried social desirability with all these other things. That's fine. Hit proceed. Oh, I can't believe that ran. Wow. I'm so excited. Cool. It ran. Okay. Do we learn anything from this? Yes, a couple things. Notice it breaks a little bit. Or a lot of it. Look at these loadings. That's a problem. Look at the loadings there. Those are super low. These loadings look fine. We got to look at all of them. Look at this. Oh, ugh. They're all negative now. Probably-ish, okay-ish. All negative here. All negative here. Oh, negative here. What happened? I hate social desirability bias. Breaks everything. Here's what happened. See if this makes sense. The one most affected was usefulness, yeah? It's because usefulness, you may recall from the EFA when we were looking at communalities, it's the thing most related to everything. So usefulness shares a lot of variance with all of the items, including social desirability bias. So when usefulness, when this was connected, social desirability bias was connected to everything, usefulness was pulled out of everything, which broke everything and flipped its sign to be negative. Ugh, I hate common method bias. I mean, it's a necessary evil. Okay, according to some. I have to teach it because you have to do it. Here we go. So what do we do at this point? Look at the guidelines. Okay, connect them. Retest validity, but we'll be willing to accept lower thresholds. We just looked at validity roughly, and if the AVEs change more than 0.3, there's a lot of bad stuff going on. Will the AVE for this change by more than 3? Yeah, it will. We're going, and it's going to be way, way lower. So we don't even have to test it at this point, but you could. So we go back here, and it says, if the majority of the factors have extreme changes to their AVE, you might consider rethinking your data collection instrument and how to reduce specific response bias. In other words, darn, what now? Because we could tweak this model, we could play with it a little bit, and we might do that for a second, see if it works. I doubt it'll work. But essentially, we've broken our model. Moving forward, if we keep that social desirability bias in our model, nothing's going to work properly. And any findings we do obtain, we can't have any confidence in them. Of course, if we remove it, and we know we had bias in our data, then we also can't have much confidence in our findings because we're not accounting for the bias. So, what do we do? Let's try to tweak it real quick. Probably won't work. Just let's see if we can tweak it. I just want to make sure I'm not saying a bad word. Is tweak a bad word here? Good, okay. Some countries that's a bad word. Okay, yeah. I've gotten in trouble before. All right. Here we go. So, what we want to do is see if we can fix useful data. First thing first, I'm going to get rid of the second order. This is not how we should have it, right? So, I strongly recommend if you're following along, don't follow along at this point. I'm just going to tweak things. And again, it probably won't work, but we'll see. So, I'm going to go like this. Hello. You want to see a cool plugin? If you highlight a bunch of a bunch of latent variables and hit plugins draw covariances.
Oh, we got the error there.
Oh, error, thank you. I was going to say, then nothing happens. Draw covariances, there we go. Draws those covariances for you. That's kind of nice. Okay, let's run this one more time, see if it works. Oh yeah, change the constraint there. Make it consistent. Okay. Let's run this. Proceed. Please work. Let's see if it's as broken as before. Hey. It's less broken. Wow, that's way better. It's not great, but it's way better. Okay. Check it out, check it out. Even though they're negative, they are high. All of them are. So let's do this. Let's run the plugins. Master validity. Oh, it doesn't like that. What I gotta do is do it the other way. I don't know if it'll work with that in there. We're about to find out. Okay. We're gonna use the Excel tools real quick. Might break the Excel tools. We'll find out. Again, I just learned how to do this like last week, the new way. So I haven't had time to update all my tools for it. I'm going to get rid of everything down here with social desirability. Yeah, that should work. We'll try. We'll find out. Hey, it ran. Cool. Haha! We did it! I didn't think this would work. Ha! Woo! Wow, it actually worked.
So the problem is the second order factor.
Yeah, the problem is the second order factor is throwing it off. That's great. I'm so excited.
So is that because it was the second order factor?
Yeah, it's because it wasn't natural. That's most likely the case. It wasn't a natural second order factor. We were making it up for an exercise. So, but if you had another second order factor that was actually a natural second order factor, hopefully it wouldn't break like that. Hopefully. Well, I'm thrilled. It worked. If it hadn't worked, what would we have done? We would have written up our report and said, we tested for specific bias. When we tested for specific bias, our model broke. Essentially, the ABEs dropped by more than 0.3. So we removed the specific bias variable from our model, and we continue with caution, knowing that we may have bias in our data. It's a limitation. Okay, but we're good. So in that case, back to here, in that case, we get to move on to the next step. Excuse me, which is number 4. So if the validities are still good, then we're going to do a zero constraint test to see if it is different from 0. So what we do is go back to our model. Where'd you go? Where'd you go? Here we go. We go back to our model. We record the chi-square and the degrees of freedom, which are listed here in the notes for the model. If you look here, we record the chi-square and the degrees of freedom in the Excel tools. Because we're going to do a chi-square difference test. This is the unconstrained model. So there's the chi-square. The degrees of freedom is 615. And what we're going to do is we're going to now constrain the two. We're going to constrain all those paths now to be 0 and see if this unconstrained model is different from 0. And if it isn't, yay! If it is, boo. Okay. Here's another tedious piece. What you got to do is double click one, type 0, and then do that all that time. Or you can actually, there's a faster way. If we zoom in a bit, and I have the selection tool. Oops. You can actually highlight all the arrows and then copy the parameter constraints. Let's see if I can do this. Almost working. Just can't miss any arrows. So you can click and drag an Amos and it highlights. Hey, that worked. Cool. Now what we can do, the one at the top? Yeah, no problem. So the one at the top has a parameter constraint. What I'm going to do is I'm going to use this drag properties pillbox thing. And I'm going to grab the, or drag the parameter constraint. Click on the parameter constraint and drag it to any, oh, please work. Oh, I closed it, whoops. Move this aside. Okay, drag the parameter constraint to any highlighted one, and it'll drag to all highlighted ones. So now it's all zero constrained. We run it again, proceed, record the chi-square and degrees of freedom, which are here. Oh, that's a big difference. Oh, no, maybe not. And 650, 650. And the answer is, let me zoom in. Okay, the answer is, in a chi-square difference test, that is a big difference. There's a degrees of freedom difference of 35, a chi-square difference of 54. If you were to look that up in the chi-square distribution table, you get a p-value of 0.018, which is less than 0.05, which means these two models, the zero and the unconstrained, are different, meaning we do have bias different from zero. So we do have bias. Now, how do we deal with that? Go back to here. We did this if the null cannot be rejected, which is what we just observed. Then you've demonstrated that you have, nope, next one. if the null was not rejected, here we go. The next step is to test validities. Okay, while not constrained. We did that, so we're still good. We just need to unconstrain all those. So let me go like this, double click, get rid of this constraint, drag that constraint from here to there, good. No more constraints, save as, CFA, RMIT, SB, no constraints. Okay, and then you're on step 5. We've demonstrated we do have bias. The last test for method bias is you have to demonstrate that it is either equally distributed across your model or unequally distributed across your model. The way you do that is by naming them all the same thing. So I'm going to call this A and do the same thing we did before. Oh, there's some. Come on, there we go. And drag that constraint. This forces them all to be equal. Do a chi-square difference test. Again, between unconstrained and forced to be equal. See if that's the same or different. Put it in the constrained here. And it is 649. And the answer is, oh, just barely. Okay. You will rarely ever see an equal constraints be non-invariant. It's almost always going to be unequally distributed. So that's very normal. And so what do you do about it? I think I've written the wording in here for you. Yep, here we go. Check it out. I've written the wording for you. A test of equal specific bias demonstrated evenly distributed bias, a very uncommon, or the actual is what we observed here, a test of equal specific bias demonstrated unevenly distributed bias. That's it. For all that work, we get one line that nobody's going to care about. But some reviewer may say, you didn't test, you need to test. And now you know how. And now, what you do is you move on to causal modeling with that specific bias factor retained in there. Okay. But unconstrain this constraint because it's not unequal. All right, sorry, it isn't equal, so we need to unconstrain all that to be accurate. Okay, there we go. I realize that was painful, just as much for you as for me, probably. It is one of those necessary evils that nearly every journal will require you to do. Any rigorous journal will require it of you. If you have not, or let's say, if you've already collected your data and you don't have some specific bias variable, like social desirability, what do? You list it as a limitation, or argue why you don't need one. In fact, you don't always need one. If you have as your dependent variable something observed, like share price, or profit, or something measured, not like perceptual, something actually objectively measured, you don't need a specific bias test. Because the reason you're doing a bias test is because of endogeneity. I have a slide on this. Yes. Sorry? Yeah. Yeah, any specific bias variable. Okay. Yeah. If you didn't collect a specific bias variable, is it okay to use an unmeasured latent factor, a common latent factor? The answer is, the correct answer is no, because they tend to do more damage than good. The practical answer is, if your reviewer says you have to, either argue why you don't, or comply and just do it. So that's the practical answer. But the correct answer is no, you shouldn't. It's better to not even attempt it because it could break your model and do more damage than good. Of course, if you want an honest gospel according to James answer, I think any test of specific bias is a bad idea because it tends to break your model like we observed here. And you have very little precision. It's a very blunt instrument is what I'm trying to say. The unmeasured latent factor is even blunter than a specific bias, but specific bias is potentially more precise, yet can do more damage. So in cross-sectional data, it is a potential bias, right? If you do longitudinal data, it collects data at multiple periods, then you're in good shape. No specific bias typically associated with those. But the reason we have to collect specific bias and test for the method bias is because of this idea of endogeneity. Endogeneity is this idea that there is some third variable that predicts both of these. The example is, ignore this for a sec. I ask, what are the perceived innovative practices at your, how innovative are the practices at your company? I ask, how well is your company doing in your mind? And both of these go up. They have, as this goes up, this goes up. As this goes down, this goes down. They're strongly positively correlated. But in fact, this effect may be simply due to something else making both of them go up at the same time, like loyalty to your organization. There's a really good, I'm going to show you one moment. I'm going to fast forward for a sec. Ignore the ad.
Hi,
sorry.
are you still using Google? Because I have something really awesome to show you. It goes here.
Okay.
Have you ever wondered how related the number of people that drown in pools each year is to how many Nicolas Cage films are released the same year? Turns out there is a 66.6% correlation between the two. Or how about the fact that there's a 99.26% correlation between the divorce rate in Maine and the per capita consumption of margarine? Or a 99.79% correlation between spending on science, space, and technology, and the number of suicides by hanging, strangulation, and suffocation. Just because there is a correlation between two variables doesn't mean that one causes the other. This assumption is a logical fallacy, and yet we're drawn to headlines like, people who have more sex make the most money. Unfortunately, this does not always equal that. Even though it may look like it, cheese consumption probably isn't related to how many people die tangled in their bedsheets. But sometimes it isn't so obvious. Numerous studies found that menopausal women taking hormone replacement therapy had a lower than average incidence of heart disease, leading doctors to believe that hormone replacement could protect against heart disease. However, when women underwent randomized control trials, they found that hormone replacement therapy actually increased the risk of heart disease. When the original data was finally reanalyzed, it was found that women who took the therapy were of a higher socioeconomic group with a better diet and exercise regime. This was the real cause behind the decreased risk of heart disease. Another case found that those who used nightlights as a kid were more likely to develop myopia. But there's actually a strong link between parental myopia and the development of child myopia, so in reality, myopic parents were simply more likely to leave a light on in their child's bedroom. These are examples of a lurking variable, where A does not cause B, but rather C causes them both. It's a little like taking people who have lung cancer and thinking, hey, they're all carrying lighters in their pockets, so lighters must cause cancer, while not realizing that smoking is the confounding variable. And scientists work hard in their studies to try and avoid this. But it gets worse when popular media takes advantage of these potentially coincidental correlations. And one study about the chocolate weight loss connection was actually designed as a way to expose how science reporting can be sensationalized. A science writer with a PhD in microbiology ran a real clinical trial where participants were assigned to 3 groups: a low-carb diet plus a 1.5-ounce chocolate bar, and a group that maintained their regular diet. At the end of 3 weeks, the chocolate group did lose the most weight, but the journalist consciously used terrible science. He used 15 participants and measured 18 different measurements, including weight loss, cholesterol, sleep quality, blood pressure, well-being, etc. And when you use a small group of people and measure a large number of things, you're pretty much guaranteed to get a statistically significant result, which Veritasium has an amazing video on here if you want to check it out. The result could have easily been something different, such as chocolate correlates to lower blood pressure. If the study had been peer-reviewed by other researchers, it would have been called out. So instead, he submitted it to a journal for a fee of €600, making up a fake institution name, the Institute of Diet and Health. He then sent out a press release to dozens of media publications, and very quickly, getting slim by chocolate was front-page news. With that in mind, however, we can't dismiss correlation entirely. Correlative evidence is an essential part of science. Double-blind studies are not always possible or ethical to run, often leaving correlation as the best evidence available. When every possible causative relationship is systematically explored, correlation can be used as a powerful tool for assessing cause and effect relationships and progressing science even further. Big thanks to Tyler Vegan for providing his charts on these interesting correlations. You can check out his website or his book, Spurious Correlations, for more peculiar examples. Lighters must cause cancer, while not realizing that smoking...
Okay. This is the main idea when you get out of this. While 2 things may be apparently correlated, there may be some other lurking variable that explains them both, which really explains this relationship. In fact, when you account for this lurking variable, this effect disappears. When it comes to specific bias, it might be the reason that variables are related in your study. And if you don't account for it, you're led to believe those variables are actually related, when in fact they are not. They're related to this third thing, like the specific bias, like social desirability or loyalty or optimism or pessimism or something like that. That's why you account for method bias. Okay. All right. How we doing? We have about 1 hour left. You guys need a minute? Let's take a couple minutes.
2 minutes.
2 minutes. I know 2 minutes always becomes 15. Yeah, it's fine. Hello. Of course. Sure. The objective measures. Yeah. You don't need to do specific bias. Yeah. Nope, not at all. If a reviewer asks about it, just say, tell them that this is objective data. There's no response bias possible. It's impossible. Yeah. So they're
What matters is
oh yeah, we're doing good.
We're trying to figure out how these just
Oh yeah.
I don't.
You don't need to include these. Yes, we'll be doing causal models tomorrow night. We'll be ready. Yes. Okay. Yeah, most people don't think about it.
And just I'm not saying that it's not
because the effects didn't change. Yeah, yeah. So and I would argue that is good evidence. Yes, it is. And when it doesn't break your model, it's usually useful. Often. You can, and then if your reviewer comes back and says, no, this is heresy, it's blasphemy, and then you say, fine, we did that, that's fine.
someone finds that when you say like kind of balance. You can
yeah, and then you do longitudinal data, and there's no possible response. Yeah.
For the dependent results from one person and for the independent results.
Yeah, like a 360 analysis. Yeah. With publications, sometimes they won't let you get away with it.
And also, I come to know that even before the declaration on your preparing education, it brings some reverse coding, different scale, different encoding, maybe it's also good in favor of
it is a possibility, yes. Yes, it does.
And also, is it really important to check the modelability of the single factor first to
So some people say that, and the answer is no. But you can know. Because you're going to check the Starbucks off anyway.
And also, like, one of the is it a good idea to check the official age rather than from
right. So for example, almost nobody knows the age.
For example, in this if your model is essential.
Right. Okay.
So in the paper that I communicate send it to
yeah, in that case, you can use max bar or even the composite reliability.
What I did, I should set the efficient age, but still I should let them arrive by and
there you go. All the evidence you can have.
like I said, maybe I should show this one. Then I said, still I check that I come up with.
Yeah, that's good. That way everybody can appreciate it. Yeah. Cool. Yes.
What is PLS?
Oops.
What's that?
I need to change it. Edit.
Oh, so you mean doing the company? Oh, I see.
I just haven't changed it. Specific bias. Maybe I call this response bias from now. Response bias. Yes.
Excuse me, did anyone forget to sign or was away during the sign up session? Please.
You may have to put only known as common method bias.
Also, right. Yeah.
Missed bias, same from the missed variance?
Yes.
Okay.
Oh, it's a response bias, common method, specific bias. And
there we go. Thank you for catching that.
all right, yeah, I was right. So, do you really recommend I do step by step from that 10 steps
I
for
do.
everything?
Everything. If it's relevant to your model. Some models this isn't relevant. Like if you have objective measures or single item measures, it's not relevant. Or if you're doing a longitudinal analysis, it might be different. Or an experimental design might be different.
Yeah.
But for a survey-based cross-sectional study, this is relevant.
I'll do that now.
Ví dụ như là giảng viên này
In the state KV, do you have what to record? Like recommend. What?
I used to. I think it's still there, but it's old. I need to fix it.
Yeah, can you write? Because I see the journal now require different things.
They do. I need to rewrite it. In fact, let me see real quick. Example analysis needs to be updated. So here it is, the old version.
Yes.
But I need to update it. Okay, let's get started again. We're missing several. We'll get started soon. I think we're missing a few still. Maybe while we're missing a few, let me show you something real quick. I do hope that the StatWiki is useful for you, especially this general guidelines area. I have stuff in here that is not statistics. It's the rest of the process. For example, how to start every research project. If you're a doctoral student or even a faculty member, I don't pretend to know more than you or anything, but here's the things I have found helpful. Anytime you're about to start a research project, go through these steps and try to figure out what is the problems you're seeking to address. Why is it even important? Who else has already addressed this? And why is what they've done not sufficient? This essentially is the outline to your introduction of any paper you write, any quantitative paper you write, although it can be applied to qualitative to some extent. How to develop a quantitative model, a good one. Here's some steps for how to do these. And what do you do from the time you've developed your model to the time you need to test your model? What are the steps? You have to go find scales, for example, to build your survey. There's some advice on developing your own scales and how to pre-test them, how to do a Q-sort, how to do a talk aloud, how to find the right target sample, how to conduct a pilot study, what about IRB approval, then collecting the data, and then how to design a survey without making too many mistakes. There's a lot of stuff that goes into it. And then how to do your actual analysis. And there are other things, how to structure a quantitative paper with guidelines on what goes where, how many pages to give, what each section should include. These aren't strict rules, but these are things I've found helpful. And then this is, again, I've been to a lot of presentations, a lot of conferences, just like you guys. You've been to the good ones and the bad ones, presentations. Here are some thoughts on what to include and what not to include in conference presentation. I hope you use these. Hope you show your doctoral students if you're faculty, or hopefully implement them if you're not already. So hopefully that's helpful. We're gonna go to order of operations again. Okay, we made it down to here. We're actually almost done with CFA. I'm really excited. I was a little worried we were going slow, but we got it all in. The only things to do now are to test model fit one more time to make sure our final measurement model actually fits. And then if we want, we can impute factor scores, which I'll show you how to do. And then we're gonna go through the slides and make sure we haven't missed anything. But then that's it, we're done. And we can decide what to do with the rest of the time. So back to our model. This is the model we move forward with. We did detect we did have bias, right? And that bias was not equally distributed across the factors. So we're going to keep this in. We're not going to constrain it to be equal. We're not going to constrain it to be 0. We're just going to keep it in to parcel out those that specific bias. Now, we need to run this and look for model fit. Oh, I guess we could have just used the model fit plugin. Let's try that. Plugins, model fit. Proceed. Hopefully it works. Here it is. Okay. And at this point, all I would do is copy this table into my report. Say my final measurement model fit is this. My final measurement model. And that's it. And you can cite who and Bentler if you want. We have a good fitting measurement model that is valid. I'd report that validity table right there. I might actually exclude the specific bias because it's not super relevant and just include the other one. And that's it. That's your CFA. Yes. And up to this point, again, everything that goes into your paper is like 2 sentences, maybe a paragraph. If it's a methods piece and focuses hard on quantitative, maybe a couple paragraphs. But all these 2 days is all just condensed into a few sentences. Tomorrow's is your whole analysis section, but it'll be brief and easy. Okay.
Hi.
Yes.
Yes. Thank you. So the way that you check the common method bias that you have construct, like social design. So, like in case you don't have such construct. So how can you check the common method bias?
Okay. So if you don't have something like social desirability bias or some other specific bias variable, there are actually some other things you can do. The best possible thing you can do is take every variable in your data set. All of them. Wait. Almost. You have your validated factors. If you have your validated factors, if you have other factors in your data set that you haven't been using, throw them in there too, in your CFA, just as additional latent factors. Covary them, make them look pretty. You don't have this right now, that's fine. But then when you include all of them and covary them, what happens is some of the shared variance is pulled out. It's less biasing is what's really going on. And so if you don't have a specific bias variable, including as many factors as possible is a way to do it. Also, if you really want to, and if the reviewers really want to, you could include an unmeasured latent factor here. Some of you have seen a video for that. It's just an empty factor.
Can you show us?
Can I show you that?
I think it's very important for everyone here because normally they don't have such construct.
Okay, I'll show you it. It's not against my better judgment, but I'll show you because you will run into this. Okay. Thank you for asking. We have the time, so let's do it. So it's very similar to what we just did. unfortunately for us, these are all the factors we have in our model. Yeah, we don't have more to play with. Although we did have, actually, I can pull social desirability back in as pretend it's a latent factor. Let me do that. Except I'd rather do it this way, but you won't have it, so I'll do it this way. I'll do it this way. Okay. So what you can do is create a new ellipse here. Whee! Big one. This is an unmeasured latent factor. We don't have any items for this factor. What it's going to represent is the shared variance among all items. Anything that they all share in common, we're going to assume is chalked up to, is attributable to method variance. Even though I disagree with that, but that's how it's written. And this is how you do it. Because really, they might have trait shared variance. And now you're pulling out the trait shared variance as well. That's why I don't like this. Anyway, but this is how you would do it if a reviewer made you do it. By the way, a reviewer can't make you do anything. Stand your ground. Okay. What you do is, like before, you have to connect it to everything. Don't follow me because I have a plugin you don't have yet, but if you want to go get it, it's over here. It's in the plugins folder. It's called the CLF plugin. But I'm not going to walk you through that right now. We've already done this before. But it is called the CLF 24. That's the one I'm going to use in just a sec. So what you do is you highlight a variable, go to the plugins, run the common latent factor connector, and that connects all of them. So that's what this new plugin is going to do, by the way. It's going to make all these connections for you. And then you run this model and see if it doesn't break. Proceed. Hey, it didn't break yet. It actually ran, I mean. Okay, now notice what happened. The factor loadings on useful got destroyed. I mentioned before, useful is very connected to everything. So what's happening here? Again, this is pulling out all the shared variance, whether that's method or trait or even error. And because usefulness is so strongly connected to everything else, all of the shared variance attributable to usefulness is also being pulled out. And so now usefulness breaks to some extent. So that's what's going on. But procedurally, what I would do here is I would do a chi-square difference test between this and the zero constrained model. So let's do that. Here's the unconstrained model. 10. And let's go constrain it to 0. Now I used to make it so that you could go like this. Let's see. This will happen sometimes. Amos will turn something red, making it inactive. You can't mess with it. I'm going to have to save as RMIT ULF, UCL, ULC, unmeasured, UML, unmeasured latent factor, unmeasured latent ULF, CLF. Let's call it CLF. CLF. Okay. And now I have to close it and reopen it. All right, there it is. It's not red anymore. I should be able to, I think, click it. Plugins, CLF. Nope, didn't work. Oh well. All right, so what we have to do is we have to add that constraint as we did before. To 0. And then highlight all of them. Missing a few there. We can get a few more. Let's see. And that one. There's a 0 down here already. I'm not sure how that got there. Okay. And drag in the 0. There we go. Do the chi-square difference test. And it's that and 545. And the answer is they're different. So essentially the interpretation is the bias being detected by the unmeasured latent factor is different from 0. So we do have bias, as indicated by that approach. But again, I disagree with this. This is not a good approach because it's pulling out trait shared variance. Also, Podsakoff and McKenzie agree at this point that it's a bad approach. And they're pretty smart guys. I'd listen to them. But that's how you do it. Okay. Okay. The next step, the last thing in a CFA is moving from here to there. The next step would be a causal model. And there are 2 different ways to do this. You can use this latent factor model, which I recommend. I strongly recommend you use this model as to do your causal model. And the way we do that, actually, we had a specific bias model. This one, okay, this one. The way you would do that is you would go back and look at your model, figure out what it was, figure out what the DVs are, IVs, and that mediators. And start drawing your model in that way. The way to do that is to use your X marks the spot thing to delete covariances between any endogenous variables. In this case, that'd be our mediators and dependent variables, such as useful. And anxiety is an independent, playful is an independent, decision quality is dependent. Information acquisition is dependent, and comp use is dependent, or mediator. So, everything except those, right there. And then, you can start moving things around. This is going to be a mess, because we have, let's see if this will work. Oh, that's going to be a mess. All right, I'm going to leave that one right there. And move that one? No. It's because of the social desirability factor. Here's essentially what you need to do. You need to draw arrows, causal arrows, between everything the way they should be. So we need to go from anxiety to useful. We also need to remove variance constraints. So we have this variance constraint. Now that we're not in the CFA, we can't constrain its variance to be 0, or 1, because we're actually going to predict its variance. So we need to move that constraint back over to the indicators. You may ask, why did we do it in the first place? It's because when we did our metric invariance test, it had to be moved over there. So we could constrain all the indicator paths. So, you got to go and unconstrain these. Those could actually stay the same, but because they're exogenous. It's all right. So just stick it on the top one. There's actually rationale that should say you should stick it on the strongest loading one. It doesn't make much of a difference, honestly. I've tried both. Okay, then you start drawing those arrows. Comp use. There's going to be a mess since they're not where they should be. We can move them in a moment. And then usefulness predicts decision quality and information acquisition. Comp use predicts information acquisition, decision quality. Let's move it around a little bit. Let's see, I'm going to move it without moving the items. So there's anxiety at the beginning with playfulness. Useful is going to be in the middle, along with comp use. Decision quality is over here. That is one beautiful mess. That's our model. Yeah. Clean it up. Oh, magic clean. Let's do select all. Clean it up. Okay. Once you get to that point, is anyone actually following me and doing it with me? No? Good. Okay. 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 you need to add error. You're now predicting things, you have to add error. So that's that box and head. Anything that's being predicted needs error. That would be any of your endogenous variables. Let's see, right there. And then you need to name those errors. Plugins, name unobserved. And now you're ready to test your theory. So let me save this as causal latent, RMIT. And we run it. Proceed. Up arrow. Okay. We're missing some paths still. Oh well. We're missing the path from useful to decision quality. Let me throw that in real quick. Okay, one more time. Here's another reason I hate method bias tests. They make for a mess. All right. Okay, here's our model. And what we learn is, hard to see, this is a 0.3 here. This one, 0.30. Usefulness predicts decision quality pretty well. Usefulness does not predict information acquisition very well. Comp use, probably not a significant effect, but we can detect it in just a sec. Comp use up to information acquisition, it's a 0.05, I think, so not significant, most likely. Here's a strong effect, 0.42 for playful to comprehensiveness of use. So there are regression weights. We can see the R squares if we go like this. I should simplify. Let's simplify this a little bit. If we go, here, I'll just save this. If I go back to this, here's our final CFA. We can extract factor scores and make life a little bit easier. You just go to Tools, nope, Analyze, Data Imputation. We extracted factor scores in PLS, the latent variable scores. We extracted factor scores in the EFA, and now we can do it in the CFA through data imputation, lightning bolt. Nice. Okay, so that was Analyze, Data Imputation. Proceed, it runs it just to make sure it works. And then it asks what kind of imputation do you want? You want regression imputation. You want to name that new data set. It's going to create a new data set with the new variable scores in it. Just hit impute. And hopefully it runs. This says it did run. Close. So what did this do? Created a new data set. And we can go see that data set over here. Data, here it is right here. In this new data set, if I open it up in, yes. Open it up, we can see there are new variables at the very bottom. These guys. These represent our factors that we had in our CFA. It's just like before when we created those factor scores in the EFA, same idea, but during a CFA. And these account for the specific bias of social desirability and the parceling out of that bias. So now we can use these either in SPSS, in regressions, or ANOVAs, or we can use them in AMOS to draw our models. Yeah, let's do that again. So the way you go from here to getting factor scores, up at the top, Analyze, Data Imputation, and then run the model and use regression imputation and hit impute. And that'll do it. That'll create a new data set. And what you can do with that, if I go File New, I can actually pull in that new data set and the variables in the model I can just pull out like this. Zoom in. I can just create the model like this and start drawing arrows between these instead. They account for all of the measures we had. What the difference is between this and the big mess I was creating is this one has fewer degrees of freedom. So model fit will probably be worse. It also doesn't account for error as well. So estimates will be a little bit different. Yeah.
Can we calculate the factor score from the CFA before we run the model?
Can you calculate factor score from a CFA?
Yes.
Before you run the model?
Yes.
Before you run this?
The data set. Instead of you run the SEM bench, you compute the factor score. And then you rerun it to make it simple. So we calculate the factor score after we achieve the confirmatory factor analysis, and we calculate the factor score, then we run it as a model. Yeah, instead of, yes, you can just calculate the factor scores right after you're done with the CFA and use those new factor scores to draw your model. However it is we were drawing it. Like this, is that what you were asking? Like you don't have to use the fully latent model. You can, and I strongly advise it. It is messier and it doesn't work as well in a setting like this. But in your own study, I do recommend the latent model. Did that answer your question? So this can be used, right?
Yeah, you can use this. Most people actually do.
Even without opening the SPSS, without going to SPSS and without doing factor analysis, you are asking you open the AMOS. And then you do the CFA, and then
we run the CFAs, and then we use the factor score from the CFA because it's more accurate.
Yes.
I'm using the factor score from EFA.
Oh, is that what you were asking? Oh, yeah. Which is more accurate, the factor score from EFA or CFA?
Yeah.
No, I just want to explain what the professor said. Like my saying is that because I don't care about EFA much because. We still have to run CFA, so that's why I prefer to use the factor score from CFA, and calculate it from CFA, and then I use them as a data set to run the SEO.
Yes. Yes. You are correct. You can do that. Yes. Yes.
Do we have the reference
for using
for the data imputation?
The reference for using data imputation,
Cascadation.
Cascadation.
No.
No. Let's see. A lot of people use them. You could probably cite any number of people. Is there a specific one? Let me see if I have one here. Oops. Latent variable systems. I want score. Factor. I want factor score. No. I don't have one on the wiki, but if you went to Google Scholar and searched for latent variable scores, yeah, if I go to Scholar, search for latent variable scores in quotes, then here we go. Here are a bunch of citations where they use latent variable scores. Yeah. I bet Joe Hare wouldn't mind citing his book either. Okay. That's actually it for CFA. Yeah. So let's look really quickly through these slides. We have 30 minutes. Excellent. Okay. I'm going to see if there's anything I haven't covered that I need to cover. In these slides, it's a bunch of reference material for you. It has all the thresholds and things like that. It tells you what all the measures are, which measures to pull out. This is maybe something I should mention. Causes of poor model fit. This specification is a common cause of poor model fit. If you have formative factors that you're modeling reflectively, that can cause bad fit. If you have first order factors that should be second order, or second order factors that should be first order, that can cause bad fit. Over specification, meaning you have too many arrows in your causal model, that could cause, it decreases your degrees of freedom. Having bad validity issues, neglecting your assumptions in the data screening. A large sample size, believe it or not, can affect model fit. A large sample size inflates your chi-square. So does model complexity, the number of variables you have in your model. So all these things can have an effect. What can you do to fix it? I didn't talk about this. Ooh. Let me show you something. I'm actually not a proponent of this anymore, but I should show it to you real quick. Let's say you don't have good model fit. Let me go back to a CFA.
You have a sample of poor data set so that we can play around with that.
Do I have a bad data set you can play with?
Yeah.
Because the one I have is very good. It's very clean. Yeah.
You know what I mean?
Yeah, I know what you mean.
Yeah.
I actually have variables in that data set that are not very good.
Right.
Yeah. If you use the unfaithful measures or the multi-purposing measures, they're very lame.
Yeah.
Yeah. And so you could play around with those. But real quick, before, let me just do this and get rid of this real quick. If you have a CFA and you can't obtain model fit for some reason, you can, if you want, look at, in the output, look at the modification indices. We have a fairly complex model, so I'm going to bump this up to 40. Modification indices are based on the chi-square. And so the more complex, the higher the indice. So I'm going to run this. Again, I'm not a big proponent of this, but it does reveal some issues. If you go to your output, we look at our model fit. Notice our CFI is 0.934. That's not more than 0.95. What if we had to get it up to 0.95? We could go here to modification indices and look at what's causing some problems. These modification indices tell you how your chi-square would change if you changed what it's suggesting. It is telling me here that error 19 and error 20 are highly related. So are 3 and 4. If we go look at 19 and 20 and 3 and 4, let's see, here's 3 and 4. That's usefulness 3 and 4. If I go look at the wording of those variables, usefulness 3 and 4 are down here, right here. And these say very similar. Excel, using Excel in my work increases my productivity. Using Excel enhances my work effectiveness. Essentially the same thing. If I answered one strongly agree, I'm going to answer the other one strongly agree. And they're in the middle of the scale, so I probably stopped paying attention by now. And I'm just answering systematically. And what Amos is saying with these modification indices is that, yeah, they're almost always the same number. So we don't need them both. So if we got rid of one of them, let me hit the up arrow and see which one has a better loading.
Alternatively, we can let them correlate.
So yeah, sometimes we've let them correlate, and when they're systematically correlated conceptually, then that is justified. Although after talking with Jagdeep Singh, he strongly discourages it. Yeah, he said he would rather see us delete an item than correlate.
Because this will affect the convertibility and discriminant.
It biases some things. So both of these are fairly strong.
Look, the E is E19 and E20.
And also 3 and 4. They were both.
Oh.
Yeah, both.
But the one.
Sorry?
Sorry, can you go back to one?
Yeah, I'd have to, let's see. Here.
I see the effect of
19 and 20 is bigger. Yeah.
Yeah, that one bigger. So potentially you only need one.
True. Let me try 19 and 20 first. 19 and 20 belong to playfulness 5 and 6. Playfulness 5 and 6 up here is right here. I'm inventive, I'm creative. Same idea, right? So let me get rid of one of them. And 19 and 20, the lower loading is going to be, they're about the same. So I'm just going to get rid of one of them. I'm going to get rid of the second one. Sorry, what? Why do I not correlate them? Because Jagdeep says, I'm referring to authority at this point. Jagdeep says that that can create biases in your data, and it's artificial rather than natural.
Yes,
I don't have a better answer than that.
Yes, written something on it.
I don't know that he's actually published anything on it. Yeah. But before, we might just covary those two errors, and that would account for it. If I run this again, I'll do that with 3 and 4. We'll see. Okay. Let me go to the output. We'll go to model fit. Remember, it was 934. Now it's 939. Almost there. Let's go ahead and covary, just so you can see the difference here. 3 and 4. 3 and 4. Covary between errors because they are systematically correlated. As a side note, if you covary your errors and then run a method bias test, it almost always breaks.
But conceptually, it makes sense, because
You're creating it's an artificial relationship that's between error. Yeah, it doesn't make a lot of sense. Notice my chi-squared, or my CFI did improve substantially. But we get essentially the same effect when we delete one of those items. And we have redundant items, so it's not so bad. But that's what modification indices are. They show you where you could change your model. But we'll look at those again with our causal model tomorrow. Okay.
Hi. I think the CFA,
Uh-huh.
I mean the threshold for the CFI, it's not, it don't need to be high too much. It's more
Right.
than
0.9 is fine,
0.95.
especially for a very complex model like that.
Yeah. It just can, like, more than 0.9. That's
Yeah, 0.9 is fine with for a complex model. Yeah. We talked about that, and that, and that, and that. Exercises, extra time. I think I would like to do one-on-one. We had several questions. We have only 25 minutes left. Unless there's a specific request for the general. Yeah, I can explain those real quick. Standardized residual covariances. These are like modification indices, but different. I'll show you. Excuse me. If you go to your output properties and check the box for residual moments, what will happen is it will plot in a big matrix all of the differences in the chi-square comparison, the covariance matrix comparisons, but for the residuals. And when you have more residuals, more error, you inflate the chi-square. So if we can find out which items are causing the biggest errors, we can find out which ones are causing the chi-square to inflate the most. So if we run this and look at the output and go to estimates matrices, it produces this massive matrix right here. If you were to copy this over to my stats tools and go to the fit check tab, paste this in there and click the button, it will tell you exactly which problem or which item is causing the most problems. Anxiety 7 is the biggest problem. It is the one causing the most inflation to the chi-square. So at this point, if we deleted anxiety 7, we should improve our CFI. Let's try it real quick. And delete anxiety 7. And run this again. See what the CFI is now. See if it's above 0.95. Model fit. Look at that, 0.949. Really close. Because we removed the item causing the most error, inflating the chi-square the most. So that's standardized residual covariances. Okay. that's all for today. We're gonna do some one-on-one. I'm gonna stay till I have a meeting at 5. Okay, so I have a meeting at 5, but I'll stay till 5 and help you out one-on-one. Tomorrow we're gonna do causal analyses. The causal analyses aren't that complicated, and I am almost positive we will finish by lunch. But we have somebody talking to us tomorrow.
Yeah.
Maybe after lunch.
Find out, yeah.
Okay, well,
Yeah.
we'll have to figure that out because
Yeah. Why don't we make it like we finish by 3?
the thing is, we'll cover the causal analyses easily.
Right.
Easily in the morning.
And then we look at some of your.
We can do one-on-one stuff.
Yeah.
My concern is if it's one-on-one, people will leave.
Yeah.
We can talk about this. We'll
Yeah.
figure it out. Show up in the morning, but there's a possibility after lunch there won't be a lot of lecturing going on. So.
Can you use one of the participant data?
Yeah.
Because I think your data is perfect.
It's beautiful, but okay, this is a great idea. If there's time tomorrow and people want to stay around and see problematic analyses and watch me sweat a little bit, and get my stomach in a jumble, then I'll use somebody else's data and try to work miracles on it. It's happened before. I actually fixed some guy's dissertation on live. It was great.
All right. Thank you, everyone. Could you bring your rapishes, the teacups and things, just here, please, so that it would be easy for the cleaners. And yeah, tomorrow, see you at 9 a.m. sharp. Thank you.
Thank you.
So you can stick around until 5.
I'm not showing up at all.
Yeah. I tried many times and I couldn't. Here's the file.
Okay, let's try something else.
Yeah.
Thank you. There we go. And did you try right-clicking it and opening it as
I did
administrator?
that. Yeah. No, I didn't.
So running as administrator might fix the problem. Nope. So did you identify whether there were actually plugins in there?
Yes, I've also tried that. This one, yeah.
So here's where we need to go. Users, and who are you?
This one.
This guy right here?
Yeah.
And app data. Local. It's not there. Huh. Oh.
Maybe programs.
No, it's it's not going to look there. It's going to look for Amos development. You're missing a bunch of stuff here.
How about if we show
Like create it?
or not, just search for
We did that. We did that.
It won't be there. But we could make it up. Maybe? Check this out. Amos development. See you. Let me write it over here. Amos development. Amos. Amos. Because this is where it's going to be looking. 20, right? 20. And then plugins. That'd be so crazy if this actually worked. And then, and where is that plugin?
You mean policy?
Yeah, did it go like the downloads folder or
this one?
Here. No, that's the one folder we just created. So
on Google Drive, you mean? Huh?
Sure. Did you download the? Here.
This one.
Okay. Yeah. So let's do this. We're not saying.
Okay. Just retry.
Okay. Weird. It's just right there. There it is. It's in your downloads folder, probably. Oh, don't click on it. Removed. It removed it. Nice. All right. Well, let's just see if it works first. I don't know if it's actually going to work. We're just making stuff up at this point.
I said we'll run EFA with
Good.
my data.
Okay, that'll be fun. Good. Okay. So download. Keep. Show in folder. And here, oh, we have a bunch of them. Okay. So, all right. Properties. Unblock.
Oh, okay. So maybe it was blocked, huh?
Well, that's part of the problem. But the other problem is this folder didn't exist. So now it's open. Oh, Amos is already open. Okay, let's see. Let me just make sure what version we have here. It is version 24. Okay. Close Amos. Open as administrator. Like I said, it'd be crazy if this actually worked. No, it didn't work. So I don't know what causes that. I wonder if it's just like a bad installation of Amos or something. Because it didn't install all the folders. Have you had any other problems with Amos? Just this one.
Sorry to interrupt. Because it's taught by different teams that we are not authorized. So maybe that's why.
They might have blocked the plugins. So the plugins, they're driver files. And driver files are potentially hazardous. They can change your registry and all those things. So I bet that's what happened.
So ask them for the plugins.
Ask them, say, hey, just tell them when the program is installed, it's supposed to create this folder, this Amos development folder, but it didn't.
Okay. What's the significance of these plugins?
It just speeds things up. That's it.
So I can do everything.
Oh yeah. It's just harder.
Even if the model is very complex, I can still do it without the plugins.
Yeah. The plugins didn't exist till I made them. Yeah.
Oh yeah.
And people still had to do the statistics.
You have done a great favor. So many researchers.
Thank you so much.
You're welcome. Sorry it didn't work.
Should we start?
Okay. So did you have a question beyond that?
Yes.
Okay.
I was wondering about the rationing. But it won't take long.
Okay. Are you going to the meeting at 5 or not? Maybe not. Then you're not. Okay. There were some students invited to the meeting at 5. Okay. I don't know anything about Rush. So what would have your question be? Over the phone is probably really tricky. They're welcome to email. I answer every email that comes to me, usually within 24 hours. Sure. Okay. Or they can ask me directly. I get emails from people all over the world every day. People I don't know. Which is why we email me. Okay. Oh, the CLS?
Yeah,
yeah, it's just on the Google Drive thing. Yeah, it's already there. But the new one, the one that does the new stuff, it's not there yet. We're still making it.
So you have many plugins.
Other ones. Yeah.
So how can we find on?
I think, are those in there? I don't know if those are in there. Let's see. Where are you? Oh, they're in there. Like erase all, erase selected, magic clean. Yeah, they're all in there in our Google Drive folder. They're all there. Yeah.
Yeah, right. Yeah, just quick one. I remember yesterday we talked about sample size, and then we talked about the more sample size you get, the less value that you have.
See the screen. Yes.
Yeah. You said, but for large sample, there's ways to.
Yes.
Can we speak about that tomorrow?
So we talked about effect size.
Yes.
In PLS, we looked at the F squared.
Okay.
And
you said there's ways.
There's another way you can do a random sample. I didn't show random sampling, did I? All right. Bring it up tomorrow. I will have time for it, for sure.
That'll be awesome.
So random sampling. Yeah. Yes.
We are doing this postgraduate experience tomorrow.
Oh, sure. Yeah. Oh,
yeah.
Okay, yeah, sure.
Yeah. Just half.
Yeah, half. But we don't have the screen.
Oh, did you want something in the background? Oh, that was probably terrible. I just went.
I think we have something in background.
Oh, the statistic thing, the complicated.
I don't know. Oh, this screen may be better. I don't know.
Okay.
We'll just unmute this screen. HTML. There it is. Here you go.
Oh, yeah.
And then
Like fancy.
something like that. But then there's this. Maybe from the TV is better.
Caleb, please join us for the conference.
Yeah.
It's gonna be in Slack.
I don't know. Maybe the white is also bad.
Oh, okay. So, yeah.
Sure. Okay, great.
क्या करने लगा यार करवा रहा ना से हाँ ऐसे मैं भी कुछ सीख लूँगा
Is the white background is too much?
I'm on level 7 ठीक है I'm on level 7 बैठ के पढ़ूँगा
Did you have a question before? I'm going to do some big stuff with him.
I'm just ready.
Okay. Yeah.
Okay, so you guys come.
So there are different schools of thought. More recently, I've been persuaded to not do that anymore. The other time I would do it. If you had random let's see where the items couldn't complete one of those. Yeah, covariant is best, yes. Maybe 7 items. Yeah, I wouldn't delete any of those. The covariant is justifiable. There's a way to argue it, and I don't know if they. I know they can talk about it.
So it's how long? I just
Few is possible. Few is possible. In order, it uses artificiality that biases your model. You just want to get to adequate fit. Not adequate. And beyond that, stop covariant. Oh, I need to stop recording. Let's see, stop share. There we go. End meeting. The